Good afternoon. We have a full agenda, so I will call this meeting to order and just give a few guidelines before we get started. Since this is not session, I hope we are informal and have a discussion. I invited Clean Water Council members to come to this meeting, and the LCCMR authorized its members to come to the hearing, and one has come, that is Jeff Broberg, and we welcome him as the Vice Chair of LCCMR. What we are going to go over today are reports that have come out since the end of session. There will be 3 of those. We posted this hearing so folks would have a chance to sign up, and a number have signed up. But if you are in the audience and would like to testify in the public testimony section and haven't signed up, that's okay too. We will be taking public testimony because there is a lot of interest. I just call your attention to some of the things that we have put in our pockets. Besides the minutes, and there is some information. Some of it you've seen before for members, and some not. It came in at the end of session. I just wanted to draw your attention to the hydrologic areas of concern done by the Minnesota Department of Natural Resources. This is an April report. We have a similar report that's older from the Met Council, and so I think it's relevant so people can see areas that we might be talking about. Also in your packet is something that was seen by the Senate, and there were some good slides in here. It is only partial. The slides that were just pretty pictures are not in here. These are only the slides with specific information, and I call that to your attention because House Counsel may refer to it, as well as to this list of communities and organizations who have treated their drinking water for excess nitrogen. With that, let me start by noting this piece in your packet, and this is the first thing. This is a Star Tribune article of September 3rd, and it was on the business page. And in the business page, the article says that the North Central region, including Minnesota, are projected to be a #1 place to live in 2032. According to a recent Gallup analysis. And the study that Gallup did had 13 metrics. One of them was access to clean, safe water. And that's where we rated highest. A futurist, Joel Barker, who is not associated with the study, said that the water access should carry even more weight in ranking rather than only being one of the 13 equally weighted categories. So looking to the future, and I think we all know this, water is getting to be more and more important, not less and less. So with that introduction, we would invite up Dave Wall of the MPCA to give the nitrogen report that was issued shortly after we left session.
Madam Chair, members of the committee, my name is Rebecca Flood. I'm an Assistant Commissioner for Water Policy at the Minnesota Pollution Control Agency, and we appreciate the opportunity today to present our various reports to the committee and foster a discussion. I would like to introduce Dave Wall. He's a hydrologist with the Pollution Control Agency and was the principal project manager for this first study, nitrogen in Minnesota surface waters.
Madam Chair, members of the committee.
Just for procedure, I think we're going to let him go through unless there are technical questions, and then we will take questions afterward. But we will keep the list as we go along, so if you have questions, be sure and let us know. Welcome to the committee.
Thank you. Madam Chair, members of the committee, my name is Dave Wall. I'm a hydrologist with the Minnesota Pollution Control Agency, and it is an honor to be here today to discuss the findings of a report that was released in June. The title of the report is Nitrogen in Minnesota Surface Waters, Conditions, Sources, Trends, and Reductions. The report was a collaborative effort. We have 15 authors and co-authors, and we worked very closely with the University of Minnesota. The University of Minnesota led the analysis of agricultural cropland sources of nitrogen, and they also helped with the practices to reduce nitrogen getting into surface waters from agricultural sources. The U.S. Geological Survey assisted with the trends evaluation, the trends over time, as well as some modeling. This study was prompted by a legislative directive in 2010 asking the MPCA to develop total nitrogen and nitrate standards. Additionally, the study was prompted by the Gulf of Mexico Hypoxia Task Force. They had asked the primary states contributing nutrients down to the Gulf of Mexico to develop a strategy to reduce nutrients coming out of each of these primary states contributing the nutrients. We did this study to work towards protecting Minnesota waters and downstream waters. In Minnesota, high levels of nitrate can harm aquatic life, and the MPCA is currently developing standards to protect the aquatic life from the toxic effects of high nitrate. Additionally, nitrate, the nitrate form of nitrogen, has long been a concern with drinking water supplies, getting into well water and creating potential health concerns if nitrate exceeds 10 milligrams per liter. We also have 15 streams in the state, cold water streams that are potential drinking water sources, which have nitrate that are exceeding the standards for drinking water as well, the 10 milligrams per liter. For downstream concerns, we are trying to protect the Gulf of Mexico, which has a large low oxygen zone or hypoxia zone, south of Louisiana. We're also protecting Lake Winnipeg as the Red River flows north into Canada. Lake Winnipeg has algae blooms, largely caused by phosphorus, but they also believe nitrogen has a role. And also we're the headwaters for some Iowa rivers, such as the Des Moines and the Cedar, which are experiencing high nitrate and concerns with drinking water. So in summary, we care about nitrogen because high concentrations can harm aquatic life, contributes to hypoxia in the Gulf of Mexico, and it can exceed the drinking water standards. Before I get into the findings, I just want to show one slide here on different forms of nitrogen. Nitrogen has several forms, and it can transform from one form into another. In our most polluted waters, in the high nitrate streams and rivers, the nitrate form of nitrogen is going to be the dominant form. We see that continuously being the dominant form in our high nitrate rivers. So if we're looking at total nitrogen or we're looking at nitrate, and we're looking at maps or graphs, I'm going to show you both, total nitrogen and nitrate, the findings are approximately the same as whether we're looking at the nitrate or the total nitrogen, because nitrate is the dominant form in these high nitrogen surface waters. The topics I'm going to cover are the conditions, what's the extent of the problem, the sources, where is it coming from, what are the trends over time, and then lastly, some options for reducing nitrogen from getting into surface waters. This map shows the results from over 50,000 water samples. Each point on the map represents a stream sampling site that was sampled somewhere between 15 and over several hundred times. The concentrations we see are high in the southern part of the state, as indicated by the red circles and the red and the orange circles, and are low in the northern part of the state, as indicated by the green and blue circles. If we look at what's coming out of each of our watersheds, these are the loads, or the amount of nitrogen, the flow times the concentration, the amount of nitrogen coming out of each of our watersheds over the course of a year. And so this is monitoring information from 2007 to 2009. And it shows a similar pattern where southern Minnesota watersheds have the highest amount of nitrogen leaving the watershed per year. Northern Minnesota with much lower amounts of nitrogen leaving the watersheds, with south central Minnesota being the highest area of nitrogen loading. We also compared the monitoring results with the U.S. Geological Survey's primary model for modeling watershed nutrient levels, the Sparrow model. And the Sparrow model shows, again, a similar pattern. Southern Minnesota with the highest amounts of nitrogen leaving the watersheds, northern Minnesota with a much lower amount. If we look at what's leaving the state in the Mississippi River and heading down the Mississippi River in the direction of the Gulf of Mexico, we find that a third of the watersheds that contribute water to the Mississippi River provide 3/4 of the nitrogen amount, or the nitrogen load, entering the Mississippi and leaving the state. And those watersheds are largely those southern Minnesota, south central Minnesota watersheds. So now if we look at what is leaving the state on an annual basis on average, in the southeastern part of the state there at the Iowa border, we see 211 million pounds of nitrogen leaving the state per year on average. And if we go to the northwest, in the Red River, we see a much lower amount, about 37 million pounds leaving the Red River heading towards Lake Winnipeg. As far as one of the parts of the state that does have high nitrogen is the Minnesota River Basin. And we see about half of what leaves the state in the Mississippi River is flowing down the Minnesota River, 116 million pounds per year at Jordan. The Twin Cities, if we compare what's coming into the Twin Cities in the Minnesota, the Mississippi, and the St. Croix rivers, and what's then leaving south of the Twin Cities, we see about a 3.5% increase in the total nitrogen that is added from the Twin Cities areas, or at least that's the difference between what's flowing in and what's leaving the Twin Cities. Now I'll jump to sources of nitrogen, and there are many different sources, and each source can create water quality problems locally. We're going to look statewide and look at the results for the entire state, but recognizing that any particular source can be an issue locally. There's agricultural sources, cropland sources. There are urban sources, such as domestic wastewater, industrial wastewater, and urban runoff. And then there's other miscellaneous sources, septic systems, forests, atmospheric deposition, barnyard runoff, to name a few. I want to now highlight two terms here, two types of sources, the cropland groundwater and the cropland tile drainage. They're very important sources, and I want to make sure we're clear on the terms and what they represent. If we look at cropland groundwater sources, what I mean by that is nitrogen that gets into the groundwater and then flows into the stream. A relatively low amount of nitrogen gets into surface waters from overland runoff, going over the land. But the majority gets in the subsurface, so it moves downward through the soil, and if it escapes, if there's not roots there to take it up, then it can keep moving down into the water table, and then gradually, and sometimes this can take decades, the nitrate will move into the surface waters. As it moves into the surface waters, there can be losses of nitrogen, and these losses can be almost 100%, or they can be very little, depending on how fast the flow is and the conditions underneath in the bedrock and in the aquifers. Now, tile drainage works similarly to begin with. It's a downward movement through the soil, and then instead of keeping moving down into aquifers and on into streams, it is a routing. It enters pipes a few feet below the surface, which then moves on down into surface waters fairly rapidly, without that same type of loss that occurs in a more natural system through the groundwater. So if we look on an average precipitation year at the sources around the state, we see that 72 to 73% of the nitrogen enters surface waters through the agricultural cropland sources, the green shaded areas there. 30% from the cropland groundwater pathway, 37% from the cropland tile drainage pathway. Cropland runoff, as I mentioned earlier, is a smaller source, but contributes 5% of the nitrogen load on average. Point sources, the municipal and industrial wastewater sources, contribute an estimated 9%, and most of that is the domestic or the municipal wastewater. 87% of it's municipal wastewater, 13% being industrial wastewater. Atmospheric deposition into lakes and streams accounts for 9% of the nitrogen. This is from both precipitation and from dry deposition. There are some other miscellaneous sources. Urban stormwater is a fairly small contributor at 1%. Forests have very low nitrogen. There's very low amounts of particularly nitrate nitrogen that gets into waters around forests and below the ground from forests. However, there is so much forest land, and some of the nitrogen is organic, that we do have some amount of this nitrogen attributable to forests across the state. It all adds up to about 7%. Septic systems, about 2%, and feedlot runoff, less than 1%. Now, of course, these sources vary in different parts of the state. So here, each bar represents a major river, a major basin in the state, and each color represents a different source. And you can see that from one river to another, from one basin to another, the sources do vary. The red being tile drainage is much higher in some watersheds, some air parts of the state than other parts of the state. Same with cropland groundwater and point sources. This can be shown more clearly on this slide here, which we've got the Minnesota River Basin and the lower Mississippi. The lower Mississippi is the basin that is in southeastern Minnesota and includes the karst region. And in the Minnesota River, 67% of the nitrogen gets in from tile drainage, and cropland groundwater is a much lower contributor at 18%. However, the lower Mississippi, we see that cropland tile drainage is 23%, and the cropland groundwater dominates at 57%. Also, there's more nitrogen getting into surface waters from crop runoff in the lower Mississippi, where we have different landscape, of course, than the Minnesota River. In this study, we did look at comparing dry years, average year, and wet year, and precipitation has a very important role in affecting the nitrogen amounts that are getting into our rivers. If we look at the Minnesota River on a dry year, it's about 25% of what we see getting into the river on a wet year. And also you can see in the other major rivers that the amount of nitrogen is much lower in the dry year as compared to the average in wet years. So precipitation plays a major role. Now, of course, these are estimates of findings, and with estimates there is a range of uncertainty. And we wanted to compare the findings of our sources with other results so that we can have more certainty concerning these sources and know that we are painting a relatively accurate picture of sources around the state. And so we did look at comparing the findings with watershed monitoring results, with literature reviews, scientific studies that are published, with statistical and non-statistical analyses of our watersheds and water quality. We looked at models such as the Sparrow model and other models such as the HSPF model in the Minnesota River Basin. And this is all documented in the full report and showing that the findings from these 5 ways of checking our sources compared fairly close with what we were saying in terms of the major sources. Now, when we looked at the watershed characteristics around the state, we had a number of watersheds that had good data for average flow conditions in recent years. And these watersheds are highlighted on the map, with the red being the highest nitrogen watersheds and the greens being the lower nitrogen watersheds. And if we look at the amount of tile drainage, at least the estimated amount of tile drainage in the watersheds, we see that the very high nitrate watersheds have about 35 to 45% of the watershed tile drained. And then as you have lower and lower nitrate amounts, there's less and less of the tile drainage in the watershed. Now, this doesn't mean that the tile drainage is the only factor affecting the nitrate levels. It means it's an important factor. We looked at 15 other variables to see what is affecting, at least where the correlations are between the nitrate levels in the rivers and what's going on in that watershed. And the tile drainage seemed to be the most important factor, but certainly precipitation levels, the amount of the depth to bedrock, where you've got shallow soils, that's a more sensitive area than where you have deeper soils. Now, up to this point, we've been talking about sources to waters. I'm going to just show one slide here that relates to sources to soils. This is not to be equated with sources to waters, but gives us an idea of what's that pool of nitrogen that's in the soil that can then have the potential to move out of that soil and into waters. The green bars represent the agricultural sources. The blue bars are non-agricultural sources. The soil itself, the soil organic matter, and the fertilizers are the largest contributors to that pool of nitrogen in the soil, followed by legumes like alfalfa, clover, manure, atmospheric deposition to crops. By comparison, their very small sources are municipal sludge, septic systems, and lawn fertilizers. I'm going to move now into the trends over time. The U.S. Geological Survey worked together with the MPCA to look at 52 sites around the state, and we looked at nitrate concentrations that were adjusted for flow, so we took the climate and the precipitation out of the picture. And what we saw was that along the Mississippi River there were increases since 1976 at all points, and sometimes more than a doubling, or often more than a doubling of the nitrate concentrations. Now, the nitrate concentrations north of the Twin Cities are quite low, so a doubling or tripling of the nitrate up there is not the same as in other parts in southern Minnesota, where there's much higher nitrate concentrations to begin with. But we saw the nitrate levels increasing since 1976 at all of the points along the Mississippi River. So of the 52 sites around the state, we saw increases at 35 sites since 1976, with no trend at 11 sites and a decrease at 6 sites. But what's been going on more recently is also asked, what about the past 5 to 10 years? So we did look at that period of time, 5 to 10 years prior to 2010, and we do see that there are fewer increases, and some of those increasing trends have shifted to no trend or decreasing trends. One of the areas of the state where we are seeing more recent decreases is the Minnesota River. And in the lower Minnesota River, this shows the percent change per year in that period. It's mostly affected by the period about 2004 to 2010, where some decreases were observed. Now, the nitrate levels are still very high in the Minnesota River Basin. They've come down. They came down a little bit, but they're still very high. Now we'll shift into the reductions. Again, the University of Minnesota helped us with looking at options for reducing nitrogen from agricultural sources getting into our waters, and then I'll end with a slide on municipal reductions, municipal wastewater reductions. When we look at the amount of nitrogen reduced in a given field in a treated area of land, we see that there's different practices and they have different effects in terms of reducing nitrogen levels getting into surface water. The types of practices generally fall into three categories. One is fertilizer management, which is more optimal management of nitrogen fertilizer rates and timing of application. And we can see in a given field that already has high nitrogen levels, we can get 10 to 25% reductions through those practices. And if we move to the red areas, that's tile drainage treatment. So what comes towards the end of the pipe in those tile drainage systems can be treated, and if it goes into a wetland, a constructed wetland for treatment purposes, you can get 50% reduction. Now these practices each have a fairly wide range in them, so these are average conditions, average treatment, but recognizing at any given field it may be much higher or lower. The third type of practice in green is the vegetative cover option. And vegetative cover roots are very effective at taking up the nitrates. So when you've got roots in the ground, and they can scavenge that nitrate and pull it out of the soil so it doesn't get on down into tile drainage waters or groundwater. If corn or row crops are changed to perennials, we can see a 95% reduction in nitrate levels in that given piece of land, given and below that piece of land. Cover crops also add more roots and more vegetation in the shoulder seasons in the fall and the spring, and we can see a 40% reduction or more with cover crops. However, some of the research the university was looking at was showing challenges in establishing those cover crops. So on average, the cover crops were reducing nitrogen closer to 10%. Now, the previous slide, this slide I showed you, is looking at the field, at the treated area. Now, recognizing that you can't put these BMPs, these best management practices, these options for reducing nitrogen everywhere. There are restrictions in the landscape. In some cases, the farmers are already putting on optimal rates of fertilizer. And some areas you can't put a constructed wetland. The landscape isn't suited for it. We only have so much riparian and marginal cropland for the perennials. And so this is a slide then that shows the percent reduction that can be expected statewide if these best management practices are put everywhere that is suitable for them. So it reduces the amount of nitrogen that gets into surface waters to generally less than 10% per practice. However, what we were looking at also is not just per practice, but what if you had multiple practices and you had some fertilizer rate optimization, you had some treatment of the tile drainage waters, you put in perennials at different places, and as you add up these different types of best management practices, then you start to see some significant reductions. So as we look at statewide, these three categories of practices for reducing nitrogen, we see on the left that about a 13% reduction could be expected by optimal rates and timing of fertilizer application, which would amount to a $77 million savings. The University of Minnesota used a agricultural economist in developing their tool to evaluate these types of practices, and so there's some cost estimates here as well. If we then want to get up to an 18% reduction in the middle bar, we can gain another 5% reduction statewide through these tile drainage treatment practices. at a cost of $74 million per year. And then to get up to a 30% reduction, we'd be looking at adding vegetation, more roots on the soil, cover crops, perennials, and that would cost approximately $1 billion more per year. But these costs are subject to change with fluctuating markets. As research develops and cover crops can be established more effectively, the costs would go down. As perennials can be used for other purposes and forages as well as energy crops, then the cost would also likely come down from that $1 billion a year. Now, the previous slide was statewide. If we look at a given watersheds, the picture changes a bit. And for the Root River watershed, where there's less tile drainage in southeastern Minnesota, there's less potential to reduce the nitrogen from in that red part of the bar through the tile drainage treatment practices. The LeSueur River watershed in south central Minnesota be looking at closer to a 37% reduction through the combination of best management practices. There are practices for reducing nitrogen in wastewater and a couple of different technologies that can result in a 35 to 65% reduction of what's coming out of wastewater as well. And wastewater is 9% of the nitrogen load to rivers overall in the state. So we could reduce that 9% by a third to two-thirds. So in conclusion, high nitrate in southern Minnesota is coming largely from the cropland nitrate leaching to tile lines and groundwater. The concentrations in the Mississippi River have been increasing since the mid-1970s. However, the Minnesota River seems to be stabilizing or decreasing as of late, but remains high. And we can reduce the nitrogen losses in rivers by 15 to 20% through optimal fertilizer management as well as tile drainage water treatment techniques. And if we need more than the 20% reduction, then vegetative cover, more vegetative cover, more roots, particularly in the spring and the fall seasons, can be added for further reductions. So that is it, and would be glad to answer questions if you have any.
Thank you, Madam Chair. A question on our page 60 in the slide showing cropland end losses to surface water statewide. When you figure those costs and benefits, are you anticipating 100% participation, or how do you judge how much would be done in any one practice?
Yeah, Madam Chair, members of the committee, the scenarios that we looked at here were assuming about 90% of the suitable lands with the practices being adopted. So we looked at what lands are suitable for the BMPs, where can we see reductions, and we looked at about 90% of those. So nearly all, but we allowed for the fact that there would be some non-adoption.
Okay, let's go down the row here. Rick, we'll just go straight down the row.
Thank you, Madam Chair. And Mr. Wall, I think it was referenced at the beginning, but I'd like to get on the record just the science behind the report. Could you go through just naming the university personnel who were involved? And I know we don't want to take a great deal of time, but as long as I've been doing this, I've heard about we'd have to have sound science. And I'd like to hear the scientific background and the vitae or the background of the folks who put together this report.
Madam Chair, members of the committee, we had quite a team of scientists working on this project. We were 15 authors and co-authors. There were over 70 others acknowledged in the acknowledgments of the report. Some of the scientists were from the Minnesota Pollution Control Agency. We had hydrologists and research scientists from the Minnesota Pollution Control Agency, but also particularly when we worked with the agricultural and the cropland sources, we were working with the University of Minnesota, and there were 5 professors or folks with doctorate degrees at the University of Minnesota: Dr. David Mulla, Dr. Bill Lazarus, Dr. May Davenport. We had Dr. Karina Fabrizi and Dr. Kian Kim from the University of Minnesota. They also had some other folks with master's degrees helping them. The U.S. Geological Survey, we were fortunate to be working with Dave Lorenz on the trends analysis, and Dave has done extensive work and teaches courses in trends analysis around the country, and was also consulting with the USGS's national experts in trends evaluation. And also with the U.S. Geological Survey was Dale Robertson, who is an expert in watershed modeling. So those are some of the folks that helped us in developing the report. We used monitoring results from over 50,000 water samples collected in the past decade, plus there were more samples that were collected to look at the trends evaluation going back to 1976. And of course, many scientists were involved in collection and organizing that data too.
Madam Chair and Mr. Wall, I have 2 questions. The first is from your display on page 9 here, where you talk about the sources of nitrogen to surface water, and I see urban runoff is a very minor component in the total here. And my question is kind of about how we rectify that in light of the fact that urban areas often are regulated and spend a lot of money on control of stormwater runoff, both in quantity and quality. Most big cities have stormwater fees and those kinds of things, but it seems like what this is showing is that the water is simply overwhelmed by all of these other sources, that the minor amount that we get from that urban runoff doesn't seem like any amount of money we spend in cities can make a difference if it's overwhelmed by the large agricultural impacts. Can you help me with that?
Madam Chair, members of the committee, and when we look at nitrogen, often people like to lump nutrients, nitrogen and phosphorus, as one and kind of think of them as the same, but they're very different. They behave very differently in the soils and urban environments and the transport to waters and their effects on the receiving water. So in this case, we were focusing on nitrogen, so we were not looking at the other potential contaminants from urban runoff. And as you pointed out, statewide, as we look at urban runoff, it's not a major contributor. There can be pockets of urban areas where you'd have higher levels of nitrate, total nitrogen getting into waters, but that is correct. Looking at the bigger watersheds and the bigger picture is a relatively small source of nitrogen. But we can't equate that to other contaminants such as phosphorus and other contaminants that are found in urban runoff.
Madam Chair, Mr. Wall, I understand that. The point I'm trying to make, though, is that people go to extraordinary means in urban areas to control the water quality, phosphorus, nitrogen, all of those things, and principally because they're regulated, I believe, in addition to their desire, yet this major source is simply unregulated source right now. Is that correct?
Madam Chair, members of the committee, we did not look at which sources. We did not try to tie in this study regulation versus non-regulation and see the effects of regulation and why we're seeing lower amounts from one source than another. It was to look at and objectively assess the science concerning nitrogen getting into our waters, the conditions, the sources, the trends, and the potential for reduction.
Madam Chair, my last question, I guess, in your report, I've read most of it. In one of the sections, you talk about yields from various sources. And it was interesting to me that when you're talking about yields from wastewater treatment in urban areas, you had a metric of yield per person, number of pounds of nitrogen per person per year. And yet that same metric doesn't show up in any of the other analysis. I mean, I assume you know how many farmers there are and what percentage of the runoff is from those farmland sources. You could do a similar equation, couldn't you?
Madam Chair, members of the committee, if we did look at urban areas to figure out, we weren't focusing, there is this graph, I would say, on the per person, but the focus really was, the emphasis was on the area, the geographic areas, for making likewise comparisons. So we looked at the total amount of nitrogen coming from an urban area and looked at a comparable sized area in an agricultural region to see how much nitrogen would be coming from that agricultural region, and found that they were not all that dissimilar. In other words, the total amount of nitrogen, if you include the wastewater and the runoff from the urban areas on a per acre basis, is not all that different than what we're seeing from the cropland on a per acre basis. We have a lot more cropland. The tile drain lands would be higher than the urban areas, and according to the analysis, and cropland sometimes gets lumped into one kind of overall category, but certainly there's many different types of crops, there's many different practices and management of that cropland. But if we average it all out, yeah, the urban areas on a per acre basis were comparable to the cropland.
Thank you.
Yes. Madam Chairman, I'm interested in on page 15, where you're looking at the percent nitrogen reduction in treated area, and you're looking at the riparian corn to perennials and marginal lands to perennials. I'm not totally sure it's a perennial, but it certainly acts like one in growing and in not needing fertilizer. But what about planting industrial hemp in those areas? I'm just asking from the agricultural perspective, not the legal perspective.
Madam Chair, if you'd care for me to address that, we did not look at that particular crop. Focus on cover crops was on a rye cover crop, and most of the research on the perennials has been on various types of grasses and on alfalfa, red clover, and those types of legumes.
Well, Madam Chairman, my suggestion is that if we moved, as Colorado is doing right now, using the federal decision to not enforce the laws against marijuana, Colorado, which is a much less good place to grow industrial hemp than Minnesota is moving to start that agricultural crop. And certainly it's something that we could start doing on a state level. I do believe that it's a much more profitable, particularly looking at Canada, where it is legal, I believe it's a more successful and more profitable crop than the ones that you just named. So it's something that I think that should be looked into, because it would help us in the arguments to say that we should move to legalize industrial hemp.
Thank you, Madam Chair. Mr. Ward, I may have missed it, but could you articulate or just restate how long the data set was collected that went into this report, just how many years we've been collecting this data, where it's kind of come from, just to kind of help understand what went into it a little bit better. Thank you.
Yeah. Madam Chair, members of the committee, the different chapters, there's 20 chapters in this report. There's about 450 pages. Each chapter used different data sets and for different reasons. For example, the trends analysis. We went back as far as we could go where we had reliable laboratory measurements of the nitrate levels. So that goes back to 1976, and we looked at 52 sites that had regular monitoring of nitrate over the course of those 35 years, 1976 to 2010. So tremendous amount of information there going back into the mid-1970s. As we look at other parts of the study, we were trying to focus on more recent monitoring and what's been going on more recently. So there are other chapters that are looking at 50,000 water samples collected over a 10-year period of time, 2000 to 2010. We have another chapter that looks at the watershed outlets, and that information was collected 2007 to 2009 and represents dozens and dozens of samples collected at each site each year in that time frame. So depends on what we're looking at, and there's various data sets and different ranges depending on the purpose of the analysis.
Thank you, and thank you, Madam Chair. So it would, at least for some of you've got fairly long-lived data in quite a large portion of the study. I mean, there's some areas where it's a little bit smaller, a few years, but the sampling should account for most statistical anomalies, or, I mean, it should be a fairly representative sample. I mean, I know with statistics you have to make sure you have enough samples going in to be able to go and derive conclusions, and wanted to just kind of understand the methodology. I know, as Representative Hansen has said, sometimes we want to make sure the science is sound, and part of that is just making sure that you have enough samples going in to form your conclusions.
Madam Chair, members of the committee, I just would like to respond that is true. And if we look at any given year, we're not going to get a picture of what's happening in our waters with nitrogen. We saw the change. I showed the difference between a dry year and a wet year in terms of nitrogen loading. And so we were focusing on long-term averages for much of the study. We're fortunate to have the Metropolitan Council's data sets. They have a really solid river loading monitoring information that goes back several decades. So we were looking at 3 decades of information, a tremendous wealth of information from the Metropolitan Council. But that is correct. We looked at long-term averages, and where we didn't have long-term averages, we concentrated on normal flow conditions so that we would not be seeing the extremes with the wet and the dry.
On page 9, you have the chart that shows that 30% of the statewide nitrogen sources to surface water come from groundwater. As I read your report, that was the most surprising thing for me to learn. You did make some references in your report to the areas of the state where you saw that happening the most. I don't know whether you want to talk about that here or wait till we get into the groundwater report. Do you want to comment on that?
Madam Chair, yeah, I'll comment briefly, and then there will be more discussion later on groundwater. Definitely, we see that in areas where we have extensive tile drainage, that tends to dominate the source of nitrogen. South central Minnesota, for example, and groundwater is a much lower fraction. You have tighter soil, you have more clay soils in that region as well. So there's less infiltration that gets down into groundwater, and more in the gets in the tile drainage and the surface runoff. But if we look at other parts of the state, such as that are less tiled, and particularly those areas that have sensitive geology, in other words, thin soils or soils that more rapidly move water from the surface downward, we do see that groundwater has much more of an influence. And southeastern Minnesota being one part of the state where that occurs, where groundwater is a more dominant source pathway. And in southeastern Minnesota, it's interesting also that we don't see the drop in nitrates so much in the wintertime as we do in some other parts of the state that are less groundwater fed, because there's a continuous supply of nitrate coming in from the groundwater even during the winter months, and so that it's a more constant level as we see more seasonal fluctuation in areas where groundwater is less of a prevalent pathway.
You didn't mention the central sands?
Madam Chair, the central sands are definitely one of those geologically sensitive regions where you can have a downward movement of nitrate that gets into the groundwater and carries that nitrate with it. As we looked at the watershed nitrogen amounts coming out of those watersheds in the central sands region, they were not nearly as high as we're seeing south of the Twin Cities, south, and south particularly of St. Cloud. But certainly from other monitoring, we know that there is a nitrate moving downward through those sands and on certain land uses in the central sands.
I take from what you're saying is that it goes down, but it pretty much stays in contrast to the southeast, where it goes down and moves out.
Madam Chair, yes, there's a difference in flow, the rate of flow. And southeastern Minnesota has many rapid pathways to the surface waters, whereas south central Minnesota and the sand plains, it can be decades before the effects reach streams. But you also will have some losses within the groundwater system as that nitrate travels the natural pathway through the groundwater system.
Representative McNamara.
Thank you, Madam Chair. Mr. Wall, on our sheet 17, the top slide is reduced nitrogen and wastewater discharge. You gave us dollar costs for possible reductions in some of the ag practices. You talk about reducing, I guess, what would it be, 3 to 6% of the total amount of nitrogen can be reduced, or 1/3 to 2/3 of the wastewater discharge nitrogen. Did you have cost estimates on what? I just remember the phosphorus in wastewater treatment was extremely expensive to get out, and it was easier just to ban some of that, and dishwasher and stuff. What is the situation here? Did you have cost estimates of what that was?
Madam Chair, members of the committee, we did not have cost estimates for the urban sources. That information was not available to us at the time of the study. And so that is not available at this time, at least was not included in the study.
Thank you, Madam Chair. And a follow-up, if I may. So is it do you know, you must have had an idea what you were talking about doing to know that it was feasible. Was it changing equipment in treatment plants? Was it relatively inexpensive, or was it just some chemicals they were going to add, or was it redoing the plants, or what kind of work is involved in doing that? Or why wouldn't they already be doing it if they could do it?
Madam Chair, members of the committee, there is certainly a cost to it. I don't know the amount of the cost. There is a cost to reducing nitrogen. But I'll mention, maybe just backing up a little bit, wastewater changes were made in the 80s and 90s to our wastewater to get rid of the ammonium that was in the wastewater, to greatly reduce the amount of ammonium form of nitrogen that was getting into the wastewater and into surface waters. And we have seen, and the study reports, a 200 to 300% reduction in ammonium levels in surface waters, and the trend results. So there was that conversion of ammonium into other forms in the wastewater, so the ammonium was not a problem getting into our surface waters. And so now we have nitrate and other organic nitrogen that is getting into surface water from wastewater sources. And yes, there's a cost to reduce that, but I don't know the specific amount.
Thank you, Madam Chair. Well, I'm trying to understand. So you know that we can do it, so there must have been something, you had some idea what you were going to do to make it happen. I'm trying to get some credibility behind what you're saying. Was it completely changing all our wastewater treatment plants to have new processes, or was it a simple little addition of something? I mean, is it a significant economic impact for our communities to consider doing this, or was it relatively easy? I'm surprised you have in the ag, you had all kinds of numbers backing up what you were thinking of here, but in the wastewater treatment plant, I'm wondering what's involved.
Yeah, part of, Madam Chair, members of the committee, part of the reason we didn't focus as much on the wastewater treatment as a smaller part of the statewide reductions. As I noted earlier, about a 3.5% increase in nitrogen moving through the Twin Cities area. We did have limited resources for the project and for the study, and so we wanted to focus our efforts on where the sources were the greatest.
Representative.
Thank you, Madam Chair. Just a quick question from yesterday's newspaper article about the amount of farmland that's being
added because of we can't get a farm bill passed, and more farmers are taking their land out of the conservation improvement or the conservation programs and stuff. Are you seeing a noticeable increase then in the nitrates that are coming off of these areas, or is it are we seeing more of that because of the additional farmland?
Madam Chair, members of the committee, it takes many years of information and data to really discern trends, because the climate is changing, there's other influences, and we don't have a long enough period of record to assess that over the state or in any given watershed. The fact that you are taking grasses, which out of production, putting in row crops, we know that grasses have a very low nitrate level that gets down below that through grasses. And so as you take grasses out, the risk of nitrate moving into waters increases in that given area. But we did not do trends analyses that would allow us to determine how the recent changes in taking CRP land out of production, the grasses out of production, and putting them in, taking the CRP land out and putting it into cropland production would have affected the water quality. And
Thank you, Madam Chair. Mr. Wall, maybe this is what you were going to say, but let's look at the opposite question and on page 14 where the decrease occurred in the Minnesota River. And I think you said that the data there was from '04 on, but the state invested, along with the federal government, millions of dollars to take 100,000 acres out of production there, called CREP, Conservation Reserve Enhancement Program. And that occurred, I think, between 98 and probably last full acres coming in 2002 or 2003. So did you look at the decrease being attributable in the Minnesota River on the nitrates because of taking 100,000 acres out of production of crops and putting it into a conservation program?
Madam Chair, members of the committee, we were not able to determine the cause and effect of the changes we were seeing in the Minnesota River and other parts of the state. We noted our focus was on, are the trends increasing or decreasing, but we were unable to, there's many factors that can affect trends, and we were not able to isolate individual changes such as the one that you noted causing the reductions. We can speculate, but we don't have definitive answers on why the nitrate has dropped from in the years about 2004 to 2010 in the Minnesota River. Madam Chair, also in reference to the previous question on the municipal wastewater treatment, there is a chapter in the report that focuses on that whole subject and describes the methods of reduction and how those reductions are achieved from municipal wastewater treatment. So that's chapter F2 in the report.
Just a comment to Representative Hansen. I'm recalling that our former fiscal analyst, Jim Reinholz, did a summary of the amount of money that we spent in the Minnesota basin up through 2009, state dollars, with the in-game of protecting the water, protecting the Minnesota River. And at that point, we had spent $927 million. And we know that the federal spending at that point was over $500 million. So, just for some reference numbers there. Representative Torkelson.
Well, thank you, Madam Chair. I was kind of focused in on that same data, the flow-adjusted nitrate concentrations and the apparent reduction or improvement in that picture. And I would like to hear your interpretation of just why you think that's happening, given that, over that period of time we've probably seen, I don't have numbers in front of me, but fairly dramatic increase in the amount of tiled acres, but yet an improvement in the concentration trends.
Madam Chair, members of the committee, as previously stated, we were not able to isolate the main factors that were driving these trends. We did, in the report, list out changes that were occurring in the lands, the types of crops, the nitrogen use efficiency, in other words, how much food we can grow and corn we can grow per pound of nitrogen. That's referred to in the report, and we've seen improvements there. We're growing more food on per pound of nitrogen. There's been other changes we noted related to manure management, and which may have an effect on the water quality too. So we did note that there are a number of different factors that can be affecting the water quality. I will point out also that the Minnesota River has highly fluctuating nitrate levels. So when we look at these trends, we can picture, if you picture a shotgun shot that taken, a shooting of 100 yards away, you're going to get a big spread of dots. And that's often what it looks like when we're looking at these trends on the Minnesota River basin. In other words, the nitrate is up and down depending on the season, depending on the time. And so we rely on the statistical procedures to pull out what is happening overall. And it did show the decrease, but we still see very high nitrate levels in those peak times in particular in the Minnesota River basin. So yeah, there have been practices which we'd expect to cause increases in nitrate levels, and there's been practices which we'd expect to cause decreases, and it's some mix of all of these factors that would result in changes in the trends.
Thank you, Madam Chair. You referenced your peaks, and you're going on a tons per acre basis, more or less. How does that look if you look at it as far as concentration in the water during those fluctuations?
In terms of what, Madam Chair, may I ask clarification, are you talking about the concentrations comparing, let's say, the wintertime versus the summertime in the Minnesota River?
At different flow rates for the river, I guess, is what my question is. When we have a lot of water in the river, we have a lot of nitrogen, but is the concentration varying with that flow?
Madam Chair, members of the committee, yes, we do see a strong seasonal fluctuation in that part of the state, in the Minnesota River Basin in particular. It peaks out in the concentrations and the loads and the amounts flowing down the river peak out in June and are highest from April through July. So it's kind of those spring and early summer months when we see the highest levels in that part of the state. That drops down dramatically in the wintertime. There's no tiles flowing. You're getting more groundwater coming in, but but the concentrations drop down dramatically in the wintertime in that part of the state.
I don't see any more questions. Thank you for a very strong report. We appreciate it. We will go now to the condition of Minnesota's groundwater, and welcome to the committee. I don't know who's coming. Sherry Cronin? Let's see, where's my...
Madam Chair, members of the committee, good afternoon. I'm Glenn Skuda, the Water Quality Monitoring Manager with the Minnesota Pollution Control Agency, and with me this afternoon is Sherry Cronin, Research Scientist with the Minnesota Pollution Control Agency, who is the primary author on a report on the condition of Minnesota's groundwater that was just released in August. So we're pleased to be with you this afternoon to share you a brief overview of the report and then take any questions you might have on it.
And I am Sherry Cronin. I'm a research scientist at the MPCA, and it's an honor to be here today to present to you the findings from MPCA's groundwater condition report. As Glenn just mentioned, this report was just released in August of this year. And this is a report that we put out approximately every 5 years that describes the quality of Minnesota's groundwater resources. And in this particular report, updates the previous condition report that was published by the MPCA in September of 2007. And in this report, we did assessments for the chemicals listed on this slide, nitrate, chloride, arsenic, iron, manganese, volatile organic compounds or VOCs, phosphorus sulfate, and also some new and emerging contaminants. And these would be chemicals like medicines, fire retardants, insect repellents. And the scope of this report focused on ambient or general groundwater quality conditions. We did not look at the amount of contamination that's near localized chemical spill sites or fertilizer spill sites. And most of the interpretations that were done in this report were based on monitoring data from the state's ambient groundwater quality monitoring networks, which are jointly maintained by the MPCA and the Minnesota Department of Agriculture. We also compiled data from nitrate data from the Southeast Minnesota Volunteer Network, and this greatly expanded the amount of nitrate data that we had in southeastern Minnesota. And in a few cases, we took information from published studies to provide a more complete assessment of the chemical. We did this primarily for arsenic, and we also took published data from the USGS, from the NACWA studies, and from a study in the Bemidji area to give us a longer period of record to look at for temporal trends in groundwater quality conditions. And in this report, we focused on groundwater that would be susceptible to human-caused contamination. Within this state, there's 14 principal water supply aquifers. I've shown here on the right, if you can see it, there's just a stratigraphic diagram of all the different rocks that underlie us in this part of the state in southeastern Minnesota, many of these which contain groundwater. And as you get to these deeper aquifers, the water can be thousands to 10,000s of years old, and so we didn't assess these because any human-caused contamination, which usually emanates from a variety of different sources at the land surface, just wouldn't have had time to reach them yet. And in this report, mainly our assessments focused on the superficial sand and gravel aquifers and also the Prairie du Chien Jordan. And first, I want to go over a little bit of background on the MPCA's monitoring network, because a large amount of the data that we assessed in this report was taken from this network. And this network has two components. We have an early warning network component, which mainly consists of shallow wells and their superficial sand and gravel aquifers, and most of these wells are 40 feet deep or less. And we look at these to understand the effects of land use on groundwater quality conditions. And we also have a set of wells that tap the bedrock aquifers as well. And our early warning network, it targets the effect of urban and undeveloped land uses on groundwater quality. We assess 2 wells in 2 urban residential settings, both those that are served by centralized sewers for wastewater disposal, and we also have a network of wells in areas where the residences are served by subsurface sewage treatment systems. And we also have a network of wells in commercial industrial areas to understand the contamination underlying these areas. And as a baseline for comparison, we also have a network of wells in undeveloped areas, and these are primarily in the northern forested parts of the state. And in addition to looking at the land uses, we also wanted to understand the effect that the composition of our superficial aquifers have on groundwater quality conditions. And we did this because our superficial aquifers, they aren't all the same. These were formed by glacial processes from anywhere from 12,000 to 2 million years ago. And if the glaciers advanced from the northeast, they left deposits that are, these glaciers advanced an area of crystalline bedrock and left deposits that were siliceous in composition. And these are where these deposits are located, as shown by the pinkish color on this map. And if these glaciers, which form the aquifers, came from the northwest or the west, they traversed areas with limestone bedrock, and they left materials that are calcareous in composition, which is shown by the beigeish color here. And this box diagram shows our general network structure. We're putting in a network where we'll have the 3 urban land use categories and undeveloped in both calcareous and siliceous aquifers. And our goal is to have a total of 200 wells with 25 in each of these categories. And since 2010, we've been installing new monitoring wells for this network. We've looked through the existing networks that are present in the state and taken all of the existing wells that we could find for this network, but we need to install the rest of them. And now to move on to some of the groundwater findings. And first I wanted to discuss nitrate, which has a variety of different sources in the environment, which you've heard Dave talk about previously. And this map here shows the nitrate concentrations in Minnesota's groundwater, and this is data from 2007 to 2011. The red dots on this map show wells where the nitrate concentration was greater than 10 milligrams per liter, and this is the maximum amount that's allowed in drinking waters. And on this map, you can see there's a large number of red dots in the central part of the state. And in central Minnesota, we found that about 40% of the wells, and these mainly tap the superficial sand and gravel aquifers, exceeded 10 milligrams per liter. About 40% of the wells in central Minnesota exceeded 10 milligrams per liter is what we found. And in southwestern Minnesota, we also found some exceedances, about 20% of the wells there. And we also found some instances in southeastern Minnesota where the wells had nitrate concentrations exceeding 10 milligrams per liter, and these would mainly be the bedrock aquifers. And in the wells where we did find the exceedances, they were places where the groundwater would be naturally susceptible to contamination. That is, there was just a thin layer of glacial deposits covering the bedrock, and the aquifer that we measured, it was the uppermost as well. And taking the data from the PCA's early warning network and from Department of Ag, we looked at the effects of different land uses on nitrate concentrations. And in this table shows the different land uses we looked at. In the second column shows the median nitrate concentrations. And what we found in the groundwater is that in underlying ag areas, the median nitrate concentration was almost 9 milligrams per liter. In urban parts of the state, nitrate concentrations were still elevated compared to background conditions, but were much lower compared to those in the ag areas, and typically ranged from about 2 to 3 milligrams per liter. And we found in the undeveloped areas, which is mainly in the forests in the northern part of the state, the nitrate concentrations were extremely low. They were, and actually the median concentration was 0.05 milligrams per liter, which is right at the limit that our laboratory can report to us. And we compiled data from about 90 wells that had sufficient data for trend analysis. And some of these wells in the Bemidji area had a record going back to 1987, but the results on this figure mainly show trend results from the past 15 years. And the yellow dots on this map show wells where the nitrate trends were not increasing significantly. The red up arrows show where nitrate concentrations were going up, and the green down arrows show locations where nitrate concentrations were going down. And overall, across the state, we found that most of the wells showed no significant trend in nitrate. Then I'm going to move on to the results from chloride, which is a concern in the northern part of the U.S. Due to the application of de-icing chemicals. And this slide here shows the chloride concentrations in the state's sand and gravel aquifers. The red dots show concentrations that are 250 milligrams per liter or greater. And this is what's called the secondary maximum contaminant level, or this is the guideline for water suppliers, so they keep their value less than this. It keeps the water from tasting salty, which a lot of people find objectionable. And what we found from our data is the majority of the sites where chloride concentrations were greater than 250 milligrams per liter, they occurred within the Twin Cities metropolitan area. And we found that about 30% of the wells in the sand and gravel aquifers in the Twin Cities exceeded 250 milligrams per liter. And this next slide here shows the chloride concentrations in the bedrock aquifers. And these generally were lower compared to those in the sand and gravel aquifers. There was one high concentration in a well in Rochester, and this happened to be a case where the bedrock was right near the surface. It was about 25 feet to the bedrock, and the well that we sampled was exactly 25 feet deep. And we also took data from the PCA's early warning network to understand the effect of land use on chloride concentrations. And I've shown this in the box plots in this diagram. The center line in the box plot shows the median concentration, and the length of the box indicates the spread in the data. And what we found with these data is that chloride concentrations underlying the urban land uses tended to range from about 45 to 60 milligrams per liter, and were significantly greater than those in the undeveloped parts of the state. And in this report, we looked at some chemical ratios to get a handle on what the sources of chloride were to Minnesota's groundwater. And in this figure shows the red dots show locations where the source was halite, and halite is the same ingredient that would be in roadway de-icing chemicals. And in fact, most of the halite purchased in the state is used as a de-icing chemical. The orange dots show what's termed an intermediate source. That could be either it might be a wastewater source, or it could be a mixture of halite and native groundwater. And the green dots show chloride sources that are just the native groundwater. And as you can see across the state, there's a lot of the wells that we sample in our network do indicate they have a halite source. And what we found looking at the data is chloride concentrations that were 30 milligrams per liter or greater often did have a halite source to them, and native groundwater tended to have a chloride concentration of 7 milligrams per liter or lower. And we had about 35 wells that had sufficient data for trend analyses, and these wells were only located in a few areas in the vicinity of Bemidji, St. Cloud, and in the northwestern part of the Twin Cities metropolitan area. And again, the up red arrows show places where chloride was significantly increased, and the yellow dots show wells that had no significant change in chloride concentrations. And what we found looking at this limited set of data is about a third of the wells showed increases in chloride concentrations, and they weren't all centered in the Twin Cities metropolitan area either. And this slide just shows time series from a couple of the wells that we had, and in a couple of instances we did see chloride going up by 100 milligrams per liter over time. And the time series on the uppermost time series is from a well in the Bemidji area, and the lower time series is from a well that's in the Twin Cities area. Next, I want to show you some of the results for volatile organic compounds, and these are chemicals that are found in gasoline or solvents, and many of these are toxic. And we wanted to look at these in the groundwater because there's thousands of sites across the state where these have been spilled. And this slide shows the wells in which VOCs were detected in the state's groundwater from 2007 to 2011. The red dots show a detect, and the blue dots show a well where VOCs were not detected at all. And I just want to point out one thing with these results is that it does include some results from wells that were installed right near contaminant spill sites. And this was done in an effort to try to use these wells for ambient monitoring as just a low-cost way to do it. And this really does affect the results from the VOCs. This slide here shows the VOC detection frequencies in wells that just represent general groundwater conditions. And in these wells, we detected VOCs less than 10% of the time. And the types of VOCs that we found, they were mainly disinfection byproducts. And these are chemicals like chloroform, bromodichloromethane. And where these chemicals, the source of these is generally attributed to disinfected waters that are used to irrigate lawns or wash cars, and it eventually just percolates down into the groundwater. And this next slide shows the VOCs and the detection frequency from the wells that were installed right near known contaminant spills. And we found a much higher detection frequency. We found these at 15 to 25% of the wells, and this was even purposefully looking at the least contaminated wells at these locations. And we also found chemicals like benzene, propylbenzene, that are present in gasoline, which is consistent with most of these wells being installed to monitor gasoline spill sites. We didn't look at trends in VOCs in this report, and this was done because a review of the time series that we had available didn't show detections frequently enough to do the statistical work. And in this particular site shows the record from solvent measurements at a well in the St. Cloud area. The blue diamonds show instances in which the solvent was measured but not detected, and there was just in the red diamond shows where the solvent was measured and detected. And in this case, there was just one detection in this well once in the late 1990s, and we haven't seen it since. And the other time series that were looked at in this report just showed similar sporadic detections. We also included in this report some information on unregulated or emerging contaminants. And this was done using published information in a PCA report that was put out in January of 2012, and also a USGS data report that was put out on hormones. And we will have another report on emerging contaminants coming out, where it will be published by the USGS and co-authored by the PCA. And we expect that to be published in early 2014. And this slide here just shows the results from our first year of monitoring, which was in 2010. The bright red dots on this slide show wells in which we detected an emerging contaminant, and the number next to the well shows the number of detections that we had. The pink dots show wells where we measured for emerging contaminants but didn't find them. And in this year, we found emerging contaminants in about 30% of the wells. We haven't found any concentrations yet that exceeded any applicable health guidance that's been put out. And we also found the largest number of detections in wells that were down gradient from closed landfills. And that concludes my presentation, and I thank you for your attention. Paul?
Thanks, Madam Chair. On the report back on nitrates, you mentioned higher levels in parts of central Minnesota where you said the wells tend to be shallower. Do you have any data that shows if you have a shallow well, by going in close proximity, digging a deeper well, what happens to the nitrate levels in a case like that?
We compiled, there's a little bit of data on that. The Department of Agriculture, they've done some sampling at some nested wells, and they've seen lower concentrations in the deeper wells. And they can probably elaborate a lot more on that than me.
Thanks, Madam Chair. Just another question then, turning to the chloride part of your report. You didn't mention, or is it a factor, salt used for regeneration of water softeners in a home setting. Is that a significant contributor to chloride pollution?
Madam Chair, members of the committee, yes, water softener salt could contribute. Halite, a lot of the areas of the Twin Cities metropolitan area where we've seen increased concentrations, they're likely served by centralized sewer systems where that water would be disposed, would be going to the wastewater plants rather than directly disposed of on the ground.
Thank you, Madam Chair. I'm interested in trends you identified in this report. On page 9, you have nitrate concentration trends. And it's a little hard to summarize visually, but it looks like things are pretty stable. Is that correct?
Madam Chair, members of the committee, yes, we generally found that most of the wells that we looked at didn't have a significant trend in nitrate concentrations in the last 15 years.
Thank you. And then a follow-up, if we then look at the chloride concentrations, it looks like we're experiencing some fairly dramatic increases. Is that a proper summarization of that trend?
Madam Chair, members of the committee, yes, we found in the limited data that we had for chloride, we found increasing trends in about 30% of the wells.
Thank you.
Representative Clark, Karen?
Thank you, Madam Chair. In this, in your detections of contaminants of emerging concern, did you do any testing for, or I see that you looked at publications, so I'm wondering if you, I didn't see anything here on perfluorochemicals, and I know there's been some published reports on that, and then I'm just wondering about, maybe this is something in the future, but the chemicals that are used in fracking, is that going to be part of something you're looking at in the future, or are any of the monitoring wells related to that, or where is that on your radar?
Madam Chair, members of the committee, this report didn't include any information on perfluorochemicals, but we are testing our ambient wells this year for the PFCs. And to date, we have not tested any of the wells for the fracking chemicals.
Madam Chair. So, okay, so around the PFCs, you're doing that now, and when would that information be available?
Madam Chair, members of the committee, we're still getting the information back from the laboratory.
Okay. And then, Madam Chair, in terms of the fracking chemicals, do you have a plan to do that, or do you need us to ask you to do that, or what would help get some of those chemicals to be tested?
Madam Chair, members of the committee, we would need to look into seeing about what laboratory methods are available first.
Thank you.
John, start with that.
Thank you, Madam Chair. Question on page 13. And you may have explained this and I just missed it, but talking about the increase in VOCs, is that, yeah, that's where, is that one still on chloride? There's a, look at the graph on, I can't read the That's a chloride increase.
Madam Chair, members of the committee, yes, that graph is on chloride.
And do you think this is attributable? I'm looking, because one of those is in my district. Is that attributable to salt application? Is that?
What we found for, Madam Chair, members of the committee, we found for a large number of the wells that the source is halite, which is the same product that's used in road de-icing chemicals. And then we've seen the sales data that show a large amount of the salt that's purchased here is used to de-ice roadways.
And how deep are these wells? Do you have that information available, or?
Madam Chair, members of the committee, these wells would be approximately 30 feet deep.
Thanks.
Madam Chair, thank you. The question I have is about the reporting limits that you have on these. And just for nitrates, for example, you report 10 parts per million. That's obvious. That's the health risk limit. 3 is the next level, and 1 to 3 is. Is there some reasoning behind that or significance to having a detection of 3? And I guess what I'm after, is there a place where we should be cautioned that we have the occurrence of these things as an indicator instead of waiting until it's too late that we have above health risk limits?
Madam Chair, members of the committee, the concentration ranges on that nitrate figure, they were shown a pic to show exceedances above the MCL and also to show the distribution in the data.
Okay. And to my second question, is there some point where we should be raising a caution when we detect these things? It's one thing to say, well, it's 10, it's over the health risk limit, it's all bad, but is there some point, and we're going to be talking later about how do we manage this so it doesn't occur? Is there some level that's significant to that? Thank you.
Madam Chair, committee members, I guess that's a policy question of when we're seeing elevations beginning, when do we start to get concerned, and what can we do about taking action toward that? Some of the data shows that in the more undeveloped areas, you've got levels that are well below 1, as low as 0.05. So we know what baseline can look like if we start to see levels climbing to 1 to 3 to 5. That is an indicator that there's something happening in that area that is elevating the levels, and prevention is always a better policy than cleanup.
Thank you, Madam Chair. And following up on Mr. Broberg's question about levels, I've got the statute book here looking back to 1989 with a degradation prevention goal that was established in 1989, almost 25 years ago, and common detection. So just taking the chloride issue, common detection means detection of a pollutant that is not due to misuse or unusual or unique circumstances, but is likely to be the result of normal use of a product or a practice. So has the agency moved towards declaring common detection for chloride?
Representative, committee members, no, we have not.
And Madam Chair, if we hop over to the nitrate issue, so it's not, the statute doesn't talk about a level, it just says non-degradation and a common detection. So has there been a common detection established for nitrate nitrogen in groundwater?
Madam Chair, members of the committee, no, there is not.
Madam Chair, and often, people come to us and want new legislation or new statute or changing statute, but here we have some things on the books, and I would encourage members to look at 103H.001 and on about degradation prevention goal, health risk limits, best management practices, common detection. Because I think regardless of whether they're ag products or whether they're commercial products or whether they're a new product, if it's commonly detected due to its normal use, we have over 20-year-old statute on the books that gives the agencies some tools to start addressing this. To get to what you just said, Mr. Skuda, that prevention is better than cleanup.
Representative Hansen, we will get a copy of that statute, email it to everyone, members of the committee, and post it on our website. I don't see any other question. Oh, I'm sorry. Representative Clark.
Thank you, Madam Chair. Well, it's kind of building on the last couple of questions. So we have these thresholds that identify, I presume these thresholds are things that are considered in working with the health department and other sources of information, that the 10 micrograms at one point is considered some threshold level of concern. Is there any place that is your agency looking at any cumulative health impact at all on any of these contaminants, or is it all just one by one, even if there's 5 of them in one area and one in another? And do you know what I mean? Is there any way for these contaminants that you're looking at any cumulative impact on in terms of health risk? And I know you're not the health department, but you do that in some other places in the law.
Madam Chair, Representative, I'd have to confer with the Department of Health on that. As you said, their agency primarily setting the levels for contaminants in water, so we work with them on that. I'm not directly involved in that. I can look into that and provide you more information.
Yeah, that would be helpful because, we could look at some maps of overlapping contaminants and see, just what people are faced with, and that would be helpful, I think.
I do see no further questions. Wait, I'm sorry. I'm just not looking up.
Okay. Sorry, one of the contaminants that I'm interested in is the chemical that's contained in Roundup. I think it's glyphosate. Is that anyone that you've looked at? Or has anyone suggested that should be looked at because of the increasing use of Roundup on corn and soybean crops?
Madam Chair, members of the committee, glyphosate is not analyzed as part of MPCA's network, but I would need to confer with the Department of Ag to see if it's monitored by their network.
We will ask them and get that to us for tomorrow.
Okay, thanks.
You can ask them. I'm going to try one more time. Members, I don't see any other questions. Thank you so much for testifying. Members, on page 16 of the original report that we heard, there were figures about, or dollar amounts attached to reducing cropland nitrogen losses to surface water statewide. There were no similar numbers of cost to Minnesotans, including costs for cleanup of wells contaminated with nitrates, whether they're private or public. So we see one side of the ledger, we don't see the other side of the ledger. And I have talked to House Research about this issue, looking at both sides of the ledger, and there's very little data available for us. But I will ask Mr. Sullivan to tell you what we know and what we don't know about our drinking water. Mr. Sullivan?
Madam Chair and members, Colbey Sullivan from House Research. In looking into this question about costs incurred by public water suppliers and their customers and private well owners to treat or avoid nitrate contamination, I learned that the costs are not known. No one has tallied or keeps track of the costs. Either for public water suppliers who are, as I'll talk about in a minute, both the public water suppliers who we all think of, the municipal and the regional water suppliers who provide your water through the pipes, and then also community public water suppliers who provide water to the public but are actually restaurants, campgrounds, churches. They're also required under federal and state law, if they have nitrate levels above 10 parts per million, to treat or avoid that nitrate level so that they're providing water to the public that meets the drinking water standards. So they also incur costs. A of ways. So I'll talk a little bit about what I found within each category. With the public water suppliers, you have in your packets an excerpt of slides from Bruce Montgomery. This is a presentation to the Senate Environment and Energy Committee in April, but I believe, if I'm not mistaken, that the same slide deck was presented to this committee early in session by the Department of Ag. On the last page, the second to last slide, you see a map, and that map shows you that roughly 20 to 25 public water suppliers are in agricultural areas are dealing with nitrate issues. And dealing with nitrate issues, as I see it, is one way of saying that they're probably incurring some costs. They may be costs to treat water that's above 10 parts per million, but they also may be costs to test water more often and to work with landowners and others to try to avoid reaching the 10 part per million level, which requires treatment. And so there are costs that are involved in that as well. And I'll point out two studies that experts in these areas pointed out to me as I did this research. One is a 2007 study called The Cost of Nitrate Contamination in Public Water Supplies. It's a compilation of interviews with public water suppliers. And here, just to be clear, we're talking about the big public, municipal, and regional water suppliers. This was funded by the legislature through the Environment and Natural Resources Trust Fund in 2005. And what the researchers found, this was University of Minnesota in cooperation with our Department of Health and the Rural Water Association, they found that the costs are in a couple of categories. The big cost that these public water suppliers encounter, of course, is installing and operating treatment systems, which, as I mentioned before, that's a requirement of state and federal law when nitrate in the source water exceeds 10 parts per million. And there are 9 systems in the state that right now, as a result of the laws, have nitrate treatment systems. They're on this landscape Excel spreadsheet that's in members' packets. They're the top. There are 9 of them, but a couple communities show up twice because they have multiple treatment systems on multiple wells. And you can see in the third column they all have municipal to indicate that we're talking about the municipal public water suppliers here. And they're in the southern part of the state, the southwest, south central, and the southeast areas of the state, which are also the areas that have been on the maps presented to you already in committee as areas that are dealing with nitrate issues or are susceptible to nitrate contamination. So based on, this is actually again from the presentation from the Department of Ag, it costs roughly $3 million to install and operate, actually just $3 million to install a nitrate removal system for a public water supplier. That doesn't include ongoing maintenance costs and operations costs. So if you could roughly look at the communities, the number of treatment systems that are in play at $3 million apiece, you could get a really rough estimate of cost. Another way that this data has been analyzed, and it was one of the findings in the 2007 report, is that it also tends to increase costs for water service customers by $100 to $200 a year. So that's another way, and that's maybe a more accurate way to look at costs, assuming that the costs are passed on from the public water system to its customers. So ultimately, the customers of that public water supplier bear the cost. But before, as I mentioned earlier, these public water suppliers and their customers may incur costs before they reach the treatment level, and that includes costs to site a new well, a deeper well, maybe to avoid nitrate contamination that's closer to the surface. And sometimes, and I'll mention that in just a second, but also more frequent nitrate testing or blending water from multiple wells so that the resulting water from maybe a high nitrate level source and a lower source is below the 10 part per million requirement. So Park Rapids is an example that's provided in the 2007 study, and you'll note that Park Rapids does not appear on this list, although they've been noted in the media recently as a community dealing with nitrate issues, and that's because the way that they chose to deal with rising nitrate levels was to drill new wells. And according to the report, interviews with Park Rapids employees, it was a cost of about $2.2 million. This is in 2005. That's the cost for 2 test wells, then drill 2 wells, and then to install an iron and manganese treatment plant. Representative Anderson's question before about drilling wells that are below the surficial nitrate levels and any issues that may come along with that. And apparently, as reported to the committee, the deeper water may have higher levels of these elements that then there's also cost then to remove those elements from the drinking water for the public. So that's the what I call the public water suppliers. But then we move to the non-community public water suppliers that are also subject to federal and state law, because as I mentioned, they're providing drinking water to the public. This includes, you'll note, they're also included in the Excel spreadsheet that you have. They're everything that doesn't have municipal in the third column. So most of the rest of the document, 52 in total, these are restaurants, they're campgrounds, schools, churches, landscape and nursery businesses, convenience stores, scout camps, golf courses, and others. There's, based on my research, very little of anything known about the cost that these entities incur. It's clear that they've been required to incur costs to install and operate a nitrate system. They aren't able to blend. They probably don't have access to multiple source water wells or sources like maybe some of the larger municipals do. So they're required then to install treatment systems. And again, I don't know what those treatment systems cost or how they compare to the $3 million a year for the public water suppliers. I suspect that they're less, and it depends on how much water they treat per year, but that's a big unknown in this area. So that's it for public water suppliers. The other category, or main category, is private wells. So these are homeowners who have nitrate-contaminated wells and groundwater, and they incur costs to avoid that groundwater by drinking bottled water or to treat their groundwater with a smaller residential treatment system. And it's important to note here, what I learned when I looked into this is that while the public water suppliers are regulated, they can't provide water that exceeds 10 parts per million. That's not the case for residential private wells. There's a recommendation out there, a best practice to test periodically and to treat if nitrate concentrations exceeding 10 parts per million are found, but there is no requirement in private homes. So then the study that experts pointed out to me here is a June 2008 published article in the Journal of Soil and Water Conservation. It's called Groundwater Nitrate Contamination Costs, a Survey of Private Well Owners. This was performed by professors at the University of Minnesota along with a researcher from the Department of Agriculture, Minnesota Department of Agriculture. And so they surveyed private well owners in the Central Sand Plains region and in Dakota County, and they found that not all people with nitrate levels above 10 parts per million take steps to treat it for various reasons. But of those that did take steps, on average, the remediation costs, and this is in, again, 2007, were $190 per year to purchase bottled water, $800 to buy a nitrate treatment system, plus $100 a year to operate and maintain it, or $7,200 to install a new well to avoid nitrate contamination. And the researchers analyzed those costs with a discount rate and came up with an average. Then if you look at the different treatment options or avoidance options that the private well owners chose, it comes to $89 per year. But it's important to note that that figure is based on private well owners who had nitrate levels exceeding 10 parts per million. But half of the survey respondents said that they would take steps to avoid nitrate contamination at that level before they got to that threshold. So as I read the study and interpret it, then this is an underestimate of costs if it's true, if survey respondents are correct in that they would incur costs before their nitrate reaches that level. So then just to summarize just the unknowns, because there isn't a current tally or even estimate really of these costs, but from the research that's available, the studies that have been done, it's possible to get an idea of the type of costs that people incur due to nitrate contaminated groundwater.
I appreciate that analysis. This is a subject that you'd think we'd be able to get our arms around here. I live in southeastern Minnesota, and another example of that is Olmsted County has a well code that you can't produce out of a well if it has, or a new well, if it has more than 1 part per million nitrates. And that makes everybody drill through the first aquifer into the second aquifer. An average 230 feet deeper well at $90 a foot. So that's adding $20,000 to everybody's well. And the net effect of that is we've condemned the shallowest aquifer. Even though we have an adequate water supply, they've deemed the risk to be too high. And in fact, our Minnesota well code says that in our karst area, you can't produce, or you can't drill and produce a new well if there's less than 50 feet of soil over the limestone within a mile radius. That is almost all of those 5 or 7 counties in southeastern Minnesota.
Just before I forget, we will make sure these 2 studies are posted on our website so folks who want to read them have easy access.
Does that mean that no new wells are being drilled in southeastern Minnesota?
Madam Chair, no, we're drilling new wells, 400 and 500-foot deep wells.
At $20,000 a well?
Well, that in addition. So those are oftentimes $40,000, and those naturally require iron or different treatments as well. And you go even deeper, and it has radium naturally occurring. So we're getting squeezed between these upper aquifers that are impacted, and that's been the exact case in Lewiston, Minnesota, where they had high nitrate levels from their 500-foot deep wells, went to 1,000-foot deep wells, and have high radium levels, both above health risk limits, so they blend the water. That doesn't feel like a very good solution to our water problem.
Well, I see no other questions. Did you have one?
So real quick question. So the costs that you're talking about there are the costs of changing sources of water. You're not talking about the human health costs yet, right? Those aren't part of what you were I didn't hear them anyway in what you were talking about.
Madam Chair and Representative Clark, that's correct. And in the public water supply study, the 2007 version, formed by university professors, they note that that's right. What we're talking about here are just direct, easily quantifiable costs, market costs of purchasing products. It doesn't include any indirect costs, the kinds of costs that you're talking about, health effects or other costs, property value decreases, or the kinds of things that an economist would attempt to put a dollar figure on.
Thank you. Members, I'll note that we have, all of this is coming up because the Pollution Control Agency is looking at a nitrogen level for lakes, rivers, and streams. And there is obviously a cost then to our aquatic species. We're not getting into that today mainly because I think they are going to have to do some work on that, those costs, as they do their statement of need and reasonableness for the rulemaking. So didn't bring that to your attention today for that reason. It's time to get into public testimony, and we will start with Doug Peterson, who's president of the Minnesota Farmers Union. Welcome to the committee.
Thank you, Madam Chair. A nice fall day, so I'll go quickly as I can here. Madam Chair, for the record, my name is Doug Peterson. I'm president of the Minnesota Farmers Union. I live on our family farm south of Madison, Minnesota, in Lac-La-Prairie County. Farmers Union appreciates the opportunity to testify briefly today with our remarks relating to nitrogen and how our organization views the issues regarding nitrogen. I'm not going to spend much time today emphasizing the point that nitrogen is an important tool for farmers, especially for farmers that grow corn who are seeking to maximize yields and ultimately make a profit. Corn prices have been strong, and in the last few years we have seen more acres planted into corn. And I think it's important to remember or to remind the public that farmers who use nitrogen do so, I believe, in a manner that would maximize the efficiency on their farm. Nitrogen equals yield, therefore nitrogen is very expensive, and there's an economy within farming that does look at the bottom line. And I just want to let you know that Minnesota Farmers Union also will be working to share the results of the reports on the waters with our membership, and we acknowledge that agriculture has a significant impact on the results in the report in certain areas of the state, and we'll be working to focus on solutions that would stabilize or lower the amounts of nitrogens, not just in our surface water, but also in our groundwater. We at Minnesota Farmers Union recognize that increased drainage and more severe weather events have put more stress on our water resources. I'll repeat that. I think sometimes fully understanding that as the increased drainage and more severe weather events have put more stress on our water resources. And I think you can just look at what's happened over the last couple of weeks with from basically a drought condition to high water conditions. Minnesota Farmers Union is currently conducting our annual county conventions. We have a grassroots organization. We have 70 counties that have Farmers Union in it, and that's how we develop our policy. That will lead up to our state conventions in November, and I've attended many of those county conventions personally, and I also have led some conversations on nitrogen use and groundwater and how it's going to affect us as farmers. And there's been a real range of opinion as to how and where we got here and how long it's going to take us to change things. We didn't get here overnight. I want to repeat that. We didn't get here overnight, and there's going to take a lot of effort and a lot of cooperation to change nitrogen in the groundwater. Minnesota Farmers Union has recently attended several listening sessions that have been put together by the Minnesota Department of Agriculture to receive input and propose revisions to the state's nitrogen fertilizer management program. The nitrogen fertilizer management plan is a blueprint for prevention or minimization of the impacts of nitrogen fertilizer on groundwater in Minnesota. We will be offering comments on that plan, and most of our members are very supportive of updating that plan. Minnesota Farmers Union supports reduction strategies and understands the importance of not just reduction strategy, but also the importance of conservation and buffers in playing a role in supporting clean water, and that is why we support the passage of a new farm bill that has a very robust conservation practice, including CSP, or Conservation Security Program, or CRP, Conservation Reserve Program. And that must tie crop insurance subsidies to conservation compliance and includes language known as sod saver provisions. They must be tied, conservation and crop insurance. Minnesota Farmers Union has supported and has a seat at the table on Minnesota Agricultural Fertilization and Research Education Council. Several years ago, Minnesota farmers supported taxing themselves to put more money into research and development of fertilizer, which has led to greater adoption of variable rates and better applications. We also belong to the Minnesota Ag Water Resource Center, and we will be hearing from Director Warren Formal later on, I believe, in this testimony about a lot of the innovative things that farmers are doing, such as bioreactors and also their methods through the Discovery Farm. Minnesota Farmers Union is an active member of the Drainage Working Group, which includes a lot of credit for drainage and finding consensus, and we want to give a lot of credit to Representative Rick Hansen. Rick is here. For finding consensus on very difficult and very controversial issues. He's done a good job. Minnesota Farmers Union participates in the NRCS, that's Natural Resource and Conservation. That is a state technical committee that's federal, that meets regular to review federal conservation programs that have an impact on our state and regional water. We also belong to a coalition of green lands and blue water that is a long-term vision for agriculture in the Midwest. It's based on getting the concept of as much value as possible from farmlands by growing crops that keep soil covered year-round, farming with continuous living cover. And I believe one of the testimonies today did talk about cover crops as a reduction of N. I encourage this committee to continue to hear updates on some of those groups and positive things going on with farming that ultimately will impact water quality. We are, as the Farmers Union, we are focused on supporting solutions that are believed to be the, start all over, I hate reading off this stuff, you know how that goes some days. We support solutions that support best management practices on problem acres addressing rapid transportation of avenues of water, adding denser plant root systems where it makes sense, further refining fertilizer rates, and increasing use of water holding conservation drainage. Minnesota Farmers Union looks forward to working with this legislature and to ensure that we have healthy, safe groundwater and surface waters, and we encourage the state agency to continue to work together with all farmers in this endeavor so that family farms in rural areas can prosper. Madam Chairman, that is my testimony. If you have questions, I will stand for that. If not, I know it's a little bit warm in here. I don't want anybody to go to sleep on, so there you go.
Thank you so much.
Thank you.
I don't see any questions. Next is George Brody, Executive Director of the Land Stewardship Project. And is Jim Vanderpool coming down with you?
He'll speak, here it is. He'll speak right after me, so we'll just go,
just
if
fine.
that's all right.
That's fine.
Madam Chair, members of the committee, my name is George Brody, and I'm Executive Director of the Land Stewardship Project. And thank you for this opportunity to testify. LSP Land Stewardship Project farmer members include corn soybean producers, grazers, organic farmers, diversified crop and livestock farmers, and they're concerned about stewardship and farmer profitability. And Land Stewardship Project appreciates the MPCA for the forthright approach to this report, the nitrogen study. And we agree that all 10 to 20 major 8-digit watersheds that were identified in the report as contributing the most nitrogen to the Mississippi River need to do their parts together to achieve goals. And the Land Stewardship Project believes this report indicates the problem is that the system of annual corn and soybean monoculture dominates too much of the landscape, and especially on sensitive soils. And that's a problem we need to address. In addition, this systemic problem results from federally subsidized crop insurance that does not have conservation compliance built in, from high commodity prices, from the interests of the powerful corporate input suppliers, commodity processors, and risk and crop insurance companies. All of this together strongly drives farmers and non-operating landowners to focus on maximum production of corn and soybeans, even on marginal lands at this point. So despite helpful programs such as the Federal Conservation Stewardship Program and others, the Farm Bill, for example, devotes far more resources to all-out production than it does to conservation. As the previous speaker noted, we didn't get here overnight. It will take a major social commitment to assist farmers to re-diversify a portion of the cropping system, starting with the most sensitive parts of the landscape. And this will be needed to achieve goals. It will require leadership from the Minnesota state and local government units, along with private entities. Through markets and federal conservation incentives, we have to find ways to encourage conservation on farms that in a way that adds up to landscape resilience and health. So I urge the agency and the committee to focus on what is needed to achieve the 30 to 45% nitrogen reduction goal from croplands. It's critical to move forward in a comprehensive way, not only with single BMPs, which has historically been the approach in the state. Instead, we need to direct substantially more resources to a focus on incorporating perennials and continuous living cover into farming systems to successfully and simultaneously address flow, sediment, and nitrogen loss, as well as biodiversity in the landscape and long-term farmer profitability options. So perennial and diverse crop rotations perform significantly better in this context, even over tile lines and especially under extreme rainfall events. So I have a few specific comments in the report. One is that Chapter D1 talks about the stream nitrogen in relation to row crops over sensitive soils, and that's defined by karst and drainage, but it doesn't talk about longer crop rotations with perennials. This is on Chapter F1, Table 2. We would suggest that cover crops also include multi-species cover crops. This is an example from North Dakota research where they've restored long-term wheat production into multiple species, and they graze it, and they've seen a 15% increase in total microbial life on these fields just in a couple of years. And farmers in the Chippewa River watershed project, or watershed, are experimenting with these rotations in corn. Secondly, the table on page F14 talks about perennials, but it doesn't list pastures as part of the perennial system. Pastures for animal production should also be listed. Livestock on the land eat perennials, and improve soil health, provide economic options. It's important that we say that these options can be economic in order to see the possibility of more of them on the land. Additionally, I would suggest adding prairie strips in the row crop into row crops and slopes as part of the perennial equation. The Iowa State University did an interesting experiment where they added portions of perennials 10-20% to row crop lands on monitored fields, 4-8% slopes, non-tiled. These pictures show losses from the soybean field in the upper reaches of that experiment. In a bad rainfall, it's intercepted by the prairie strips at the bottom and monitored. And basically what they found is even during extreme rainfall events, there can be as much as a 90% reduction in soil erosion from just 10% perennials on the slopes, at the bottom of the slopes. And 20% adds significantly more biodiversity. But those kinds of losses were also seen in reductions, I should say, were seen in nitrogen on an overland flow basis, but they also monitored below the soil and found significantly less losses under the perennial prairie strips below ground. The table on that page also talks about extended rotations. That's important. It should mention both low external input rotations that reduce fertilizer requirements, as well as organic rotations. This is the long-term study again from Iowa State University, and corn and soybean yields are similar, and tile losses were decreased by 25%, or losses of nitrogen to tile lines. The University of Minnesota has done long-term research out in Lamberton, and they found significantly improved soil quality by moving from no inputs to reduced inputs compared to high input agriculture and organic input systems. So finally, on page F117, the 35% scenario for reduction describes marginal land as being retired to perennials. Normally, I think when we hear retired, we think of taken out of production. We think the production possibilities for perennials include grazing, even on public lands potentially. They include cover crops inside corn and cover crops in rotation with corn. And in that case, the cattle can come in and eat during the year, and they can eat the turnips, for example, in the fall after dry down. It can also include long-term rotations and the kind of prairie strips we were talking about. So this can be done on a working lands basis, not necessarily on a retired farmland basis. So how do we move forward? I think the multi-year watershed initiative that was included by this committee in law may be an important step in setting clear goals, achieving change against standards over multiple years, and thinking systemically rather than in terms of single BMPs only at a time. We need to think about crop diversity. The Chippewa River watershed, it has what we call the 10% project, a partnership with the Chippewa River Watershed Project and other agencies to assist farmers throughout this watershed to incorporate perennials or nitrogen management on at least 10% of the marginal fields. The project now has on-farm demonstrations, learning networks for nitrogen management, multi-species cover crop networks, improved grazing management networks, and women interested in more conservation leasing. We also just realized that the Minnesota Nutrient Strategy is just released today. We'll have more comments about that, but our comments would similarly apply. We need to focus state resources on adding diversity to cropland. And so I'll turn it over to, if that's okay, Madam Chair, to Jim Vanderpool, who will talk about his particular farming system and how it can be profitable and address conservation. Jim.
Thank you, George. Madam Chairman, members of the committee, thank you for coming or allowing me to come in and speak
Would
to
you
you.
just put your name in the record? Just
Jim Vanderpool.
It's okay. Thank you.
I'm a farmer in western Minnesota, Chippewa County. Also, my farm is part of the Chippewa River drainage, the Shakopee Creek section of the Chippewa River drainage. We're cooperators with the Chippewa 10% project that George mentioned, and very concerned about that. The reason I wanted to speak to you today is that I particularly want to have something to say about this idea that seems to surround erosion always, that land is either row cropped or it's retired. Because I don't think that's right, and I want to describe to you a little about my farm and tell you why I don't think it's right. We have 320 acres, that's a half a section, a dinky little farm, hardly worth noticing, in Chippewa County, on which we support 2 families. We ran into trouble with our hog production in the late 90s with that price meltdown, and when we got back into that corner, we learned how to think, we switched. One way of looking at it is that we changed from an emphasis on capital and building up capital to an emphasis on management. We believe in livestock on the land, and that's what started to happen around the year 2000. We got into a cattle grazing practice in addition to our hogs, and we now keep about 80 to 125 head of stockers and dairy replacement heifers on the land at all times. We, in addition to that, have a 90-sow farrow to finish operation, which my son has more to do with running, and then we also do meat sales, and we're all fully supported on the farm. And I say that not to brag, but simply to say that this can be done, because whenever you say you're small, you get discounted. Immediately, you get discounted. Oh, well, that works for him, it won't work for anybody else. So I wanted to be as clear as I could about that. Our sows eat forages, and they produce better for us because they do. They have access to perennial pastures all summer, and part of their diet is alfalfa hay in the winter. And you'll see in a bit here how that fits with the rest of the farm. We have on our farm 320 farmable acres. That's to subtract our barns, our houses, a drainage ditch that runs through, and a few things like that. So out of the 320, we have 310 that are farmable. Our use of that is 200 in a cropping rotation. 100 is in permanent grass now. And we have 10 that's in a prairie pothole, fenced out. And we graze that occasionally late in the season. We may graze it yet this year. But if it keeps up raining, we probably won't. We use an extended rotation, a long rotation, and for purposes of simplicity, I'm going to call it a 6-year rotation. That's mostly what it is, but it's applied differently on different places of our farm so that it's not exclusively so. But our rotation looks like a crop of hay in year 1, hay in year 2, hay in year 3, and at the end of that year, we apply manure and till that hay ground. Then year 4 is corn. That's followed by oats with clover underseeded, and we're experimenting now with seeding the clover under the oats and then putting in rape and oats into the clover after oat harvest so that we can have a late season grazing practice. We can't graze straight red clover. We'll lose the cattle if we do. Following that, in the 5th year, then following that, in year number 6 is one more crop of corn. We've tilled now the red clover down in the spring of the year. We've disked it down and planted corn in the red clover. and then back around to hay again. The next year is the seeding year on hay. If I count those 3 hay years as 2 of them perennial and 1 as an annual crop because it's the year of seeding. So to be fair, let's just say that the first year of the hay seeding is not a perennial crop. It is not yet a perennial crop. It's an annual one. If I do that, we still have 55 to 60% of our acres in perennial plants every year. Because that's about 90, comes to our 66 acres of hay, that is second and third year hay, the 100 acres of permanent grass, and the 10 acres of prairie pothole. If you add that all together and put it over 310, you're going to come up with about 55% in perennial plants. Now, how are we doing? My wife and I started on this farm in 1977. We've been at it 37 years. Our son and daughter-in-law came into it about 15 years ago, and we've been farming together since that time. I'm going to give you some numbers a little bit later here that I think demonstrate my point. I need to say first, though, that from the 1990s, in a conventional production system, half of the land in corn every year and half of it in soybeans, and then switching them the next year. In that system, we were using chemicals and fertilizers. As of this year, we're certified organic and have been for 7 years. We started the organic practice in the early 2000s, 2003 or so, I think was the last time we bought crop chemicals. The year following or the year after that is the last time we bought fertilizer. In the first 15 or 20 years of our farming, in 77 through 87 through 97, say, something like that, 95, our yield, and the county FSA would verify this, ran right in around 105 to 110 bushels per acre. Farmers in the room will remember that those were the years we actually paid attention to that because it had to do with the checks that we got. This year, the Crop Scout says our corn will run 170 bushels to the acre. Last year, it ran 150. The year before that, it ran 155. Now, remember, this is no fertilizer, and it's no crop chemicals. It's an organic system and a long rotation. I have numbers written down here about our gross income, but I'm not going to share those. But I will say that from a start time in the middle or the early 90s to my gross income figure this year, we've nearly tripled the income. Now, income is always, made up of money you take in and money you don't put out, and so there's where the long rotation and the organic system bear in on it. Lately, we've begun to find out some things about cover crop, and since 2 of our annual cropping crops, the 2 corn years, are long, full-season crops, and I question whether we can get a cover crop started after a corn crop, although we may try with some rye flown on. We haven't done that yet. Our other crop is oats, and we can certainly get something started after oats, and we've been looking at what some of the farmers in North Dakota are doing and how they're bringing their soil structure back, and also bringing their wheat yields back up. And we think there's some very interesting things to look at and possibly to follow from out there, even though their climate is much drier than ours. We learned, basically, a short way of saying it is we learned to start to listen to the farm. You let the farm teach you. You study the soil structure, you study the water holding capacity of the soil, study how high your organic matter is. Watch your runoff. When I have a 2 or 3 inch thunderstorm, before the rain quits, I'm out walking in the fields and I come home soaked, because I want to know how much water is coming off of the fields, which field the water is coming off of, where it's landing, is it ponding? You watch your ponding. And I can say categorically that we have much less ponding today on the same farm as we had 20 years ago under the different practice. Study weeds, study the pests, study the rotation effects. See if you can see lines in your field where it was treated differently 5 years earlier. Sometimes you can see those lines. I guess what I'm saying really is that agriculture needs to change, and I don't understand, I guess, why that should be. Well, I understand why it's difficult. It was difficult for us. We got backed into a corner and found it hard to change, but change we did, and that's why we're here today. If we hadn't changed, we would have been history already 15 years ago. The other thing that gets said, and I'm going to just deal with this very shortly, is that there's no money in it. And I gave you some of my numbers, and if you don't believe those, that's certainly your right. But I'm going to quote you just a few lines from an article that was put together coming from the Grass-Fed Exchange Conference in Bismarck, North Dakota, quoting Bill Helming and Ellen Williams, both very well-known cattle market people. And they said that the nation's beef cow herd peaked at 45.7 million head in /75 and declined to 29.3 million head last year. Why? During that same year, chicken consumption grew from 36 pounds per person to 81 pounds per person. And it's 100% explained, Helming says, by how we do it. The system that we're using today is broken, and we've got to make some changes. We can't be bringing these cattle and these feed crops into a feedlot and then sell hamburger in competition with chicken. It just won't work. We know that it won't work. He knows that it won't work. We're becoming a hamburger society. The reason we are is because we have the recession going on. The baby boomers are going to be retiring. We've got huge private and public debt yet. We've seen no particular initiative on the part of the federal government to work us out of this. And it's going to drag on us for some years to come. Unemployment is going to be higher than it should be. Underemployment is going to be a huge thing. And people aren't going to eat steaks, they're going to eat hamburgers. And grass-fed, you can argue, although he's saying, Helming says that demand for grass-fed beef is 20 or 25% up every year. And we find that to be true from our own business, because we're in that business partly. You can argue that grass-fed can't do a finished steak. I think you'd be wrong, but you could make that argument. But grass-fed can do wonderful hamburger. And I don't think anybody disagrees with that. That's just to speak to the idea that we can't take land that's growing corn and put it to grass because we can't make any money with it. You can make money with it. And as a matter of fact, we didn't start making money until we started doing it. Thank you very much for your attention.
Thank you so much. Phyllis, did you have a question?
Yes, I guess I want to continue in the same direction that I've gone before. Is anyone who's looking at alternative cropping, looking at industrial hemp? Now, I understand the problem here is that it's not legal in the United States, but it is legal in Canada. And so we've got to have agricultural conditions similar in Canada. So I wonder if anyone has thought about looking at that for part of the alternative cropping.
If the question is directed at me, I know very little about industrial hemp, but I do know that it gets talked about regularly.
Directed to both. It's directed to both.
Oh, okay.
Okay. So,
Madam Chair, members of the committee, I haven't looked into industrial hemp. It may be part of the picture. I don't know what the market economics on it will be at this point.
well, Madam Chairman, I guess what I've pointed out is that there's got to be information from across the border, and we're not very far from that, and, I would suggest that somebody start looking at that as we start making the arguments here for legalization.
Andrew?
Thank you, Madam Chair, and I guess it's more of a comment or anything, but I just want to say that, Mr. Vanderpool, Jim Vanderpool, he's done a phenomenal amount of work, and really, I think, is a model for how people can reinvent agriculture in Minnesota, and I think he's turned a number of agricultural paradigms on their head. So he's being very modest in his comments here, but he really has shown a different way of thinking, and I know he hasn't got into some of the direct marketing things that they do, but as a business and a family farm, they really do some excellent work, and I think are really helping to go and show that we can perform in a different manner, and actually it's more profitable for farmers and young people to get started in some of these means of agriculture in which they're pioneering. So thank you for coming down and sharing your comments.
Thank you so much. I don't see any other questions, but thanks for coming. Appreciate it.
Thank you.
Warren Formal? Welcome to the committee.
Well, good afternoon, Madam Chair, members of the committee, and thank you for the opportunity to be here today. My name is Warren Formo. I serve as the Executive Director for the Minnesota Agricultural Water Resource Center. We are a research and education organization dedicated to helping Minnesota farmers address water quality concerns. Our organization is made up of 20 farm groups, including both Minnesota Farm Bureau and Minnesota Farmers Union, and you've heard from President Doug Peterson already, along with several crop and livestock groups and the Minnesota crop production retailers. Our member organizations annually reach more than 50,000 Minnesota farmers and those who advise them. Following Jim, I could tell a story about lots of farmers from Minnesota, and virtually every Minnesota farmer could tell a story about conservation and stewardship. Jim did that very well, and I think the story he tells about the system that he's developed and how it works for him is very compelling. What I want to do is talk a little bit more generally about things that prevail across most farmers. So the subject of today's hearing is nitrogen, which is a basic element comprising more than 70% of the air we're breathing, about 16% of all protein, a basic building block and a basic necessity of food production. You've also heard today that nitrogen can be a cause for concern. Those of us involved in agriculture recognize these concerns exist and are actively working on solutions. Our search for solutions is focused on two fronts: optimizing nutrient efficiency within farm systems and exploring water management treatments beyond the field. I think it's important to look at a little bit of history. Prior to World War II, the primary sources of nitrogen in cropping systems were manures, legume fixation, and organic matter mineralization. While commercial fertilizers were discovered early in the last century, little was used until the infrastructure to deliver and apply nitrogen was developed in the 1950s and 1960s. Even then, farmers typically tried commercial fertilizer only on a few acres, or they carefully watched for results from the University of Minnesota Extension Service. Once they saw, either in their own fields or in research plots, the dramatic improvements in productivity, and they calculated returns on investment in fertilizer, the use of commercial fertilizer grew rapidly. So the focus of extension programs during that era, the 1950s and 60s, was simply, please use fertilizer. In the 1970s and 80s, research began to zero in on optimal rates of nitrogen, recognizing that the marginal rate of return to nitrogen application decreases once you get to a certain point, depending on the crop, the soil type, and other factors. It's important to recognize that maximum yield is not the goal. It's economic optimum yield. We sometimes talk about maximizing yield, but within the farm community, that's always through the filter of what's practical or optimal first. So economics became a primary consideration in determining nitrogen rates during this era. So the focus of extension programs in the 70s and 80s became use fertilizer at these economically optimum rates. Beginning in the 1990s then, soil fertility researchers began to look at nitrogen beyond the field. Our own Dr. Giles Randall, retired soil scientist at the University of Minnesota, is recognized as an international leader for his work on nitrates and tile discharge across different soils, crops, and nitrogen treatments. His work, and that of other researchers since that time, built on the economic optimum research to reinforce our understanding that economic optimum rate is also an important environmentally optimum rate for any given system and season. Because weather impacts this rate so much from year to year, the precise optimum rate cannot be determined to within a pound or two until after the growing season. So within agriculture, we more typically refer to an optimum nitrogen rate range for various crops and soils. So the more recent focus of extension programs is use fertilizer, but at environmentally and economically optimum rates. So the results of this change, this evolution in science and teaching is this. Farmers today produce 3 times as much food as they did in 1960 on the same cultivated acreage. Minnesota farmers in the early 1990s harvested about 0.8 bushel of corn per pound of applied nitrogen. 10 years later, they harvested 1.3 bushels per pound of applied nitrogen, a 60% improvement in efficiency. These improvements in efficiency are due to a combination of better crop genetics, better farming practices, and precision ag principles that ensure that fertilizer rates are appropriate not only for the different farm and field, but also for different soil types within fields. Better timing of nutrient applications, products that slow the release of nitrogen until they are needed by the crop, and plant tissue analysis to allow better targeting of nitrogen applications also contribute to our gradually improving nitrogen efficiency. The fertilizer industry, recognizing the importance of improving nutrient stewardship, has also contributed. They've developed a broadly supported program based on the principles of precision ag, focusing on the use of the right fertilizer source, applied at the right rate, applied at the right time, and in the right place. Branded as the 4R program, it grew out of an industry adoption of science-backed nutrient management concepts researched at many land-grant colleges, including our University of Minnesota. Our focus on efficiency as a basic part of reducing water quality impacts reflects our stewardship ethic that requires that we both protect the environment and contribute to feeding a growing number of people. Every farmer, no matter how large or small, makes a contribution to feeding the world. And while Minnesota farmers cannot cure the political or poverty ills of many starving nations, they can work to minimize the extent to which food availability leads to food insecurity. And according to the United Nations, more than 2 billion people, nearly 1/3 of the global population, are either unable to grow or afford adequate food. We're working to improve food security through better farming. Efficiency also enables us the option to set aside some land for wildlife habitat, including land suitable for crop production in some cases. The relative balance between cropland and habitat will continue to shift back and forth with efficiency and economics as some of the primary drivers and factors. There are also more than 2 million acres of habitat associated with farms in the forms of grassland, wetland, and woodlands scattered amongst the cropland of southern and western Minnesota. Acres that provide valuable wildlife habitat, and the vast majority of farmland owners enjoy the recreational opportunities they afford and do not want to convert them to cropland. So we're working to protect habitat both locally and globally, again, through better farming. The ag community also recognizes that more may be asked of us in the future, that efficiency alone may not be enough. That's why Minnesota farm organizations are working together on research and emerging technologies that may help address nitrogen concerns, especially relative to surface waters. These new technologies include practices like denitrifying bioreactors and saturated buffers, which you've heard mentioned earlier today. And we would like to engage state agencies in learning about the effectiveness of these practices under a broad range of conditions found across the state. We would like to discuss with them our direct efforts and how we can work together to ensure that these practices are implemented in a practical, meaningful way. We also want to explore together, again, the unintended consequences and explore cost effectiveness of the various practices that are looked at. One of the programs we administer through the Minnesota Ag Water Resource Center, it was mentioned earlier, is called Discovery Farms. Discovery Farms is a network of 11 farms across Minnesota, all the way from the far northwest corner to southeast Minnesota, in which we work with farmers to gather data at field edge on nutrient and sediment and a water budget coming from their farmland. The Discovery Farm program is small, admittedly. We don't cover a lot of acres, but it's an educational tool that allows us to engage with farmers and share information beyond the old bushels per acre and pounds of inputs, and we can actually talk about water quality data on their farms. Our challenge also includes increasing the awareness of the full set of conditions that farmers experience across the state. We've got different production systems, different soil types, different expected precipitation. Across our state, we have a 60-day difference in average frost-free growing season and a doubling of water quantity or precipitation as we move across the state. Has a huge factor on not only the farm systems that have evolved in any given area, but also how they respond to water quality challenges. So then we need to recognize the practices and solutions that work under one set of conditions may not work as well under other conditions. That's why, like Jim, we need to find systems that work for every farmer and help them in that exploration. Farmers are looking for clear messages as to what is expected of them, along with scientifically defensible results that they can compare to their current production system. Farming is changing, always changing. I think back to my early years on the farm when tillage was pretty much the same on all acres. We didn't have choices. There were not multiple tillage tools available. Today, farmers have many choices thanks to innovation and invention. I remember as a young farmer growing up on the farm, my dad expressing the belief that if a little fertilizer is good, more must be better. We know better, and we farm better because of it. The key to all of this change is knowledge. My father and other farmers of past generations were good farmers in their day, but many of their practices would not be accepted today because we have the benefit of experience and learning, including their experience. Likewise, as technology advances, it is likely that what is defined as good farming today, parts of that will become obsolete at some point in the future. It's a simple part of the continuous improvement process always underway in agriculture, driven by research and markets and the basic stewardship ethic inherent in being a farmer, making human lives better while showing respect for the land. In the words of one of our recently departed ag leaders, Charles Raditz, I am a steward of the land. I want to give to the next farmer land that is in better shape than when I started. That was my father's goal as well as my grandfather's. Now, Charles spoke those words in an Earth Day speech back in 1990 at his church in Lewiston. About 2 weeks ago, Charles was buried About 2 weeks ago, Charles was buried right across the road from the farm on which he was raised and where he raised his family. Now, I know that farming and farmers are not perfect, but I think it's very important for you to know that the vast majority of Minnesota farmers share Charles's desire to improve the land while providing economically for their families by contributing to a safe food supply for you and me and countless others. For more than 100 years, Minnesota farm families have been learning and adapting and changing. The new concerns we're discussing today relative to nitrogen will likely shape much of our learning and adapting over the next decade or two. We take this challenge very seriously, and we look forward to working with all state agencies and all stakeholders towards solutions. And I thank you.
Thank you. I don't see any questions. Thank you for coming.
Thank you, Madam Chair.
I can't see this. This is my hard.
I know, Mr. Formal, I often hear the comment too that when farms are passed down to the next generation, they want to leave the land in better condition, and I know that's kind of the view my family took as well. And I think that's a very noble goal. How do we kind of reconcile that goal with kind of the trends we've seen? I mean, we probably share the same goal, but what are our results? And that's kind of the challenge I'm seeing anyway.
Well, Madam Chair, Representative Falk, conservation looks different on virtually every farm. And I know to folks who aren't familiar with agriculture, as you drive across the state, it may look like one thing. But the stewardship ethic manifests itself in a lot of different ways. And I think our challenge is to help people understand and discuss and look at that stewardship ethic, look at the challenges, and if within the challenges are different in different parts of the state because of topography and the type of farm systems that are there. Erosion may be a bigger issue than nitrates in another region. And I think it's inherent for us to really get past talking about agriculture as a thing and talking with more specific, and I think farmers would respond better if we had information that was pertinent to their type of system. So we weren't talking about all farms, we were talking about farms of a given region or livestock sector or even dairy, for example, within that, so we can provide more specificity and information that matters to them, because neighboring farms are going to do things differently, and we need to help them do it differently but well.
Well, thank you, and I guess I'm still thinking that, I mean, there's the altruistic goal of passing on land better than you started operating it, but I mean, I do find that, you know, like these reports, they're highlighting some issues. We have to solve some problems here. I mean, one's acknowledging there is a problem, but to go and say that, all right, I want to pass it on better, but, you know, it's actually passed on maybe not as well. How do we, I mean, it seems like the idea or desire to, you know, pass on farmland in better condition is something that we choose to do. But if we're not getting results, how do we get better results? And I know that one particular set of conservation practices, you know, that works for highly erodible land is not going to necessarily be the same set of conservation practices you would use on some really heavy, flat, black soil. So take that off the table, but, I mean, how do we change just kind of the overall sense of responsibility we have versus what the results are that we're seeing?
Well, Madam Chair, Representative Falk, this is a great conversation, because this is, I think, exactly what we need to the point we need to get to. In the past, I think we've generalized too much, and we need to help each set of farmers understand the challenges specific to their system. And beyond that, I think it's, in my work, I interact with a lot of farmers, and I think it really starts with showing respect and appreciation for the challenge they have, and help them understand that perhaps you have some information or someone has some information, whether it's NRCS or the university or elsewhere, that can help them address that concern that we all share and want them to work on.
Thank you, Madam Chair. A couple issues. First about your optimal rates and the calculations that are made by farmers for this. I've been through those, and they're largely predicated on the price of crops and the price of fertilizer and the target yield. Those are three of the fundamentals that go into that. And no matter how you run the calculation, if crop prices are high or fertilizer prices are low, it encourages more use with the potential for more loss. So really, and you don't discover that, like you said, until the season's over, right? And so tell me how often people evaluate that at the end of the season, and how often farmers go back and say, run their calculation backwards and say, I lost this many pounds of nitrogen per acre this year, and accounted for that in an environmental factor.
Madam Chair, Mr. Boberg, I can't say exactly how many of them do that. I know that we go through that discussion and math a lot with producers, and I would say that grain prices and fertilizer prices typically move together in such a way that if you look over time, even in this era when grain prices are relatively higher, and there tends to be this assumption that that's going to mean bigger yield goals and more fertilizer application, you need to understand that farmers buy the fertilizer first and they get the crop later. So that they actually, if they choose to apply more fertilizer, actually have a lot more dollars at risk. And I think more accurately than looking at the simple price of grain and the price of fertilizer, it's the relationship. And if you track that backward through time, it tracks pretty consistent. So you could argue that a farmer is under more pressure to really dial in their nutrient rates when prices are very low, just like you could argue on the other end of the scale. It's about the relationship. And I think farmers are looking at that very often, and I know the farmers we work with, that's one of the exercises we go through. And it's based largely on, I mentioned Dr. Gouge-Randall and some of the relationships he's determined and shown graphically for both nitrate in tile water relative to yield, and that's a chart that we work with farmers on.
Madam Chair, it's interesting to note, though, I've never seen a chart by him showing how much nitrogen loss has occurred at the end of the year once you've put in all those inputs. So if you look at this on our farming landscape now is to a large degree rented land, and then the other equation is the farm rental price. And talk to me about the work you may do with landlords in helping mitigate that. Have you seen any farm leases that regulate the level of nitrogen inputs into land?
Madam Chair, Mr. Broberg, first of all, we can get you some of Dr. Randall's information. I think you might find that interesting in terms of measuring potential losses below the root zone. The second question, you may have to remind me.
Farm rental contracts
rental
that address nitrogen loss.
Yes, and I'm not aware of any farm rental contracts that address that specifically, but I would also respond that there's a bit of a built-in year-to-year stabilizer in that while, and it was talked about earlier, phosphorus and nitrogen are very different in the soil. You can store phosphorus in the soil. You cannot store nitrogen in the same way in the soil, and I think farmers understand that, which really mitigates any desire to over-apply nitrogen for future years, whether you own the land or not.
Madam Chair, that's only partially true because the storage often is acidification of the soil. So the application of buffering is a measure in some regards of how much over-application there's been.
Most of the soils we're talking about through Minnesota, we're not operating in a range where that's really going to become a factor, in my opinion.
It does where I live. Thank you.
Thank you, Madam Chair. And I was just going to ask, I know that sometimes we get things thrown around like bioreactors and controlled conservation drainage can solve a large portion of the problem. And I just wanted to reconcile on page 15 of the surface water report. It looks like bioreactors and controlled drainage are pretty small potential solutions to the statewide problem. And I think, and I'm not going to say that necessarily Discovery Farms have endorsed, a particular course of action, but seeing that, at least what the report's saying, is that these are pretty minuscule parts of the solution. Now, they may be parts of the solution, but they're not really going to solve a big part of it. Do you have some comment about things that we can do or that we are doing?
Madam Chair, Representative Falk, I would agree. I think that the magnitude that's been assigned for how large those changes could be is probably about right given current knowledge of those practices. I think one area that could grow depends on the evolving definition of controlled drainage. I think right now we think about controlled drainage as the control structures and you close and raise the water table within a system. I think in the future we need to look at drainage configuration, whether it's tile depth and spacing in the relationship, not just thinking about one or the other, but thinking about both in tandem, that could give us some of the benefits of controlled drainage across a broader portion of the landscape, which is the biggest limitation on the currently defined controlled drainage is that it's not adaptable to a large percentage of acres.
Thank you. Madam Chair, I apologize. I really appreciate this discussion because I think we're talking about some things that really make sense. And I know with drainage, it's kind of just a Wild West, so to speak. I mean, because you've got certain people that install drainage tile one particular way, and there's not always a lot of documentation. So if a person either buys a piece of property or you're take over renting a piece of property, you don't exactly know how the subsurface structures are operating. And just having better documentation or I don't even know what the correct methodology would be, but just so we have some uniformity in how we install drainage would go a long ways, because we've got to the point now where the equipment is pretty common. You might get 3-4 farmers that say, all right, let's go and buy a tile spade together, and they're installing it however they see fit, maybe without any proper training, and then you don't know how the system's actually working.
Madam Chair, Representative Falk, good points. We could go on. I agree with much of what you're saying, and I think our role is to take all the information that we can find and make sure farmers and tile contractors have access to it, so when they're making those decisions, they apply the best technology and science.
Thanks so much. Thank you. Next, Paul Watson.
Madam Chair, members of the committee, going to see if I can get my slides up here. But to begin with, I live in southeastern Minnesota, within sight of the Mississippi River. I'm a consulting hydrologist there, in addition to being thank you very much. In addition to having an organic farming operation, which I and my family grow a variety of specialty crops. I'm also a member of the Minnesota Well Owners organization, a newly founded environmental advocacy group dedicated to protecting Minnesota's groundwater and for representing Minnesota well owners on such important issues as nitrate contamination. To begin with, I need to tell you, yesterday I was at Lambeau Field amongst 78,000 screaming Packer fans. So I do have a great appreciation for the civility in this meeting room, although the excitement isn't quite there. So I want to make three major points here today. First of all, the changes that we're seeing in our water quality here in Minnesota are really being driven by changes in our agricultural land use that I'll show you have been evident over the last 30 years. We have had 20 years of voluntary measures, really through the Groundwater Protection Act, to look at protecting groundwater. And I'm going to show you a variety of data that will just indicate that with respect to the resources, the groundwater, surface water resources, we see really no improvement. And finally, I will add to a point that was made here earlier today about a complete picture of the costs of nitrate contamination. There is some pretty obvious costs, and I will get to those. So we have been citing some of the work from Giles Randall, and I put together many years of his research in terms of crop rotation. So if you look at crop rotation and average nitrate loss and compare it to a perennial crop, alfalfa, you'll see there's roughly a factor of 30. 30 times the amount of nitrate loss for annual cropping systems versus perennial cropping systems. So let's look at the last 30 years of cropping history in southeast Minnesota. The agricultural statistical folks divide up the state into, I believe, 9 regions. And I'm just going to be looking at the region I'm most familiar with. That is the southeast region, which is the 8 or 9 counties in the southeastern corner of the state. And so from 1980, what we've seen is a very dramatic increase in the number of soybean acres. So we now have, we've gone from a 3 or a 4 crop rotation to a 2 crop rotation. And so every acre of soybeans that's been added, it has taken out an acre of alfalfa or an acre of what I'm representing, small grains, in this case oats. So if you put the previous slide together with this slide, you can see that nitrate loss are going to increase dramatically just based on what we grow. If we move from perennial systems, diverse cropping systems, to annual cropping systems, makes no difference what the rate is, makes no difference what the rainfall is. Year in, year out, Giles Randall's research will indicate that there will be a factor of 30 increase in just what you grow on the land. So if we look again at southeast Minnesota and look at just the number of acres of corn and beans, we are at all-time historical highs. So I'm going to be talking about water resources that are really in my backyard here. I'm going to be talking about a small spring shed located in Crystal Springs Fish Hatchery. It is the best flow record of springs here in Minnesota, and it has the ability to monitor flow accurately. We're going to be looking at the middle branch of the Whitewater, which is a small agricultural-only watershed of roughly about 25 square miles. And then I'm going to be talking a little bit about the town of Lewiston, which is just south and a little bit east of the Whitewater. So there's a long-term data set in Crystal Springs that we've seen a doubling of that nitrate concentration over the last 20 years. The reason that this spring is so important is that it is a St. Lawrence spring. Don't want to bore you with a lot of the geologic formations in southeast Minnesota, but what's important is that St. Lawrence formation is at the bottom of the Jordan. The Jordan is the aquifer that the vast majority of public and private wells in southeast Minnesota get their water. The whole city of Rochester gets their water from the Jordan. So we have seen a doubling in this particular spot in the St. Lawrence at the bottom of the Jordan aquifer. So one thing that you have to think about with respect to nitrate movement in aquifers in southeast Minnesota is depth is irrelevant. It will move down, it will move out. Wherever the water moves, the nitrate will move. So again, we have about a 20-year record of stream concentrations in the middle branch of the Whitewater. We have seen a steady increase in those nitrate concentrations over the period of record. Let's look at the land use as a snapshot in 2005 of what is going on with respect to agricultural land use in the middle branch of the Whitewater. What we have is nearly 85% of that land area is in corn, soybeans, sweet corn, or peas. Short-term annual cropping systems. If we look, the Whitewater actually spans 3 counties, Olmsted, Winona, and Wabasha. And if we look at some work that has been done by the Southeast Minnesota Water Resources Board in private wells in those counties, what we see is that 30% of the wells in Wabasha County are already above the health risk limit of 10 parts per million. 1 in 4 in Fillmore County, a little over 1 in 5 in Winona, and roughly 1 of 8 in Olmsted. And I've asked officials in Olmsted County why you're doing such a good job in comparison to the surrounding counties. And one thing they indicate is that because their well code does not allow for wells to be completed if they have a 1 part per million concentration of nitrate, that they end up going deeper, and therefore they find less nitrate water. The city of Lewiston, again going back to the mid-60s, has seen its municipal wells have steadily increased nitrate concentrations, and they have had to drill a new well. And again, very deep wells, it makes no difference. There are cones of depression where contaminants are actually sucked into these high-capacity wells. And so the city of Lewiston is truly in a situation where they have no good alternatives, and there are no cheap alternatives. I can take it one step farther from a watershed scale to a major watershed scale and just indicate to you that there are studies out there done on the whole upper Mississippi River Basin. The USGS completed a study in 2010 where one of the major findings of that study was that flow that was normalized for the amount of water as well as the amount of nitrogen to compare the 8 watersheds within the upper Mississippi River Basin. The one that stood out in terms of nitrate contamination is the one that encompasses the southern 2/3 of Minnesota, in addition to a little chunk of Iowa and most of western Wisconsin. So I'm going to just move on to my last point. We've been talking a little bit about the cost of nitrate contamination. If you would just Google the Minnesota Department of Health's summer 2011 issue of water line, you would see that the city of St. Peter has actually installed a reverse osmosis system that cost $18.8 million. Now, if you go to Appendix B in the 2013 draft Minnesota Nitrogen Management Plan, that plan put out by the Minnesota Department of Agriculture indicates a new nitrate removal system was considered but not constructed. Now, I think we've got a couple of messages here. We have got the right hand not knowing what the left hand is doing, and in terms of being able to research the actual costs of nitrate contamination, if you would go to that Appendix B, the Department of Ag lists all the activities it has done to try to ensure that the city of St. Peter would not need a nitrate removal system. Those are costs of nitrate contamination, all those activities. We need to put a dollar figure on those activities, in addition to the $18.8 million that the city of St. Peter spent on a reverse osmosis system. One of the things that we need to do that we're currently not doing is to come up with a comprehensive understanding of what is going on with agricultural practices. We have Ag Stats, which gives us a broad overview statewide, but because the state has different climate, different cropping practices, we need to have detailed information done on a regional basis what farmers are doing. That statute was passed by this body back in 1994. Again, it was alluded to earlier, but if you go to 103H 151 subdivision 4, the Commissioner of Agriculture and the Pollution Control Agency through field audits, and they are required to do field audits of what the BMPs or whether or not they're being adopted. That is a critical component. We can develop and promote till the cows come home. But if we don't know what people are actually doing, we end up, wasting a lot of money on activities that clearly have no discernible results in the water bodies that we're trying to protect. I can also use the Whitewater watershed that I've talked about, the one that's in my backyard. We have taken thousands of samples of every single stream in that watershed. The South Branch, the Middle Branch, the North Branch, the Logan Branch, the main stem, Crystal Springs, as I have indicated. We have done municipal sampling of the municipalities that are there. We've done some community well sampling as well as private wells. We conducted 2 fan maps in 1997 and 2005 of agricultural producers in that watershed. One of the findings was that there's been a 20% increase in nitrogen fertilizer during those 2 years. In addition, we have BMPs that have been out since 1993. They are specifically tailored to southeast Minnesota. We have no data on whether or not those BMPs have been adopted over the last 20 years. We have some bits and pieces, some anecdotal evidence, but nothing that says in a comprehensive way whether or not any of those BMPs that were developed and promoted are actually been implemented into farming operations. So last but not least, I'm going to go back to a Republican senator from Minnesota who back 22 years ago was talking about voluntary measures and how well they've worked. And he indicated back then that they simply have not worked. And he said we need to identify, allocate, specify, implement, and enforce if we're going to solve this problem. The solutions are site-specific, has been indicated here, and water quality related and in need of constant adjustment. If we don't have the political will to carry out this kind of effort, we need to acknowledge it and to put our scarce resources into some other human problem more easily solved. So I thank the committee for your time, and I appreciate you listening to me. And gladly take any questions.
Thank you. I don't see questions, so we have three people that are now coming up together. I am cognizant of the time, but we have three more folks coming up. We did not put limitations on public testimony, and it's something I don't like to do.
Madam Chair and members of the committee, my name is Chris Sigford. I'm the Water Quality Director with the Minnesota Center for Environmental Advocacy. I'll try to be brief. A lot has already been said today, and I know it's getting kind of tired out and it's pretty warm in this room. My comments go to primarily to the Pollution Control Agency's nitrogen study. We found it a particularly powerful report because it is written from the standpoint of water quality outcomes and needs, rather than counting agricultural BMP inputs and activities as we often see. As such, the report presents or demonstrates a number of very sobering points. We've seen that nitrate pollution is widespread in Minnesota. The trend in many watersheds is up. And if the report presented actual nitrate loads delivered by major watershed instead of nitrate concentrations, this upward trend would be even more pronounced due to the increased output and stream flow. The source of nitrate to our surface waters, as we've heard, is overwhelmingly from agriculture, with 30% leaching from fields down into groundwater, which is then discharged into surface water, and 37%, the largest percentage, delivered to surface water via tile drainage pipes. The report demonstrates that a full suite of vegetative fertilizer management plus drainage water treatment practices are needed to even achieve a 30 to 35% reduction in nitrate, and that has to be implemented throughout 90% of all suitable lands in the watershed. To put it another way, this is not a problem caused by a few bad actors, and it's not a problem that we can identify, address, and resolve the problem at a few sites in a few selected minor watersheds. Currently, it appears that water quality is an economic externality, and the farmers are not accountable to protecting our surface water or our drinking water supplies. It's apparent, if you look at the scope of this report, that there's a spectacular mismatch between the scale of the reductions needed and the outcomes that are being delivered by our current voluntary, publicly subsidized agricultural BMP program. We have never seen an example of a voluntary program that has achieved the widespread and significant change needed. So I know that today is about describing the problem and going through these new studies, but I urge us to start thinking about the solutions, because clearly we're not on a path where we're going to get there. Thank you for the opportunity to present comments.
Madam Chair, Representatives, my name is Trevor Russell. I'm the Watershed Program Director with Friends of the Mississippi River, and like Chris, I will truncate my comments somewhat for brevity here. Of all the information we've heard today, the most concerning but least surprising to us is the share of nitrate pollution to Minnesota's surface waters stemming from artificial drainage or drain tile systems. On an average year, that's 37% statewide, but in the heavily agricultural Minnesota River, remember, that's 67% of all the nitrates to our surface waters there. In a wet year, those numbers go up to 43% statewide and 72% of nitrates to Minnesota surface waters in the Minnesota River Basin. Statewide, 64% of our impaired rivers and 57% of lakes are impaired primarily from agricultural runoff and pollution sources. Agribusiness advocates sometimes claim otherwise. We hear three messages a lot. The first is that it's urban stormwater. I think this report makes it clear that it is not. Urban stormwater is 1% of nitrate pollution to Minnesota surface waters. That is due in part to substantial investments made by cities, developers, and others to reduce stormwater pollution throughout the state. We also hear that this problem is getting better, but in fact it's not. We saw today that there are reduced concentrations of nitrate in some portions of the Minnesota River. That's not a factor of reduced net nitrate pollution. It's a factor of higher flows. We are in essence diluting an increasing level of nitrate pollution in the river. Concentration isn't load. Concentrations can go down while net load or net mass of pollution moving downstream is actually going up. That happens when you see higher water yields or more water moving through a system, which is exactly what we're seeing in the Minnesota River Basin, and I'll touch on that shortly. Lastly, we often hear that agricultural drain tile systems are a conservation practice. That is not the case, and the numbers bear that out. And I want to talk about 4 reasons why we see drainage as the premier problem for water quality in Minnesota. The first is pollution delivery. Artificial drain tile systems are an ideal pollutant delivery mechanism. Nitrate, of particular concern here, moves with water and goes where water goes. Systems that are designed to pull water down through soil saturated with fertilizer and flush them directly to nearby surface waters are a highly effective pollution delivery mechanism, a fact borne out by the numbers in this report. The second, and more concerning almost, is net water yield. Drain tiles are designed, obviously, to move water off of agricultural landscapes into nearby surface waters. These systems reduce water residence time and rob the landscape of its natural ability to hold and retain water on the landscape. I can give you a number of examples here. I'll just give you one. St. Croix Watershed Research Station scientists documented drain-tiled subwatersheds, saw increases in runoff ratios or net water yield per unit of precipitation of 50% in the Chippewa Basin on the low end and as much as 200% in the Redwood River. This means more water per unit of precipitation is leaving the field, carrying more nitrate with it, increasing river flows, and that's why we would see increased nitrate loads, much greater increases in net water yield. We might see a small decrease in concentration, but our net pollution delivery is actually increasing. Lastly, I'll touch briefly on sedimentation and erosion. Vast tile networks flush large volumes of water into nearby surface waters quickly. This creates a fire hose effect that erodes stream banks, bluffs, ravines, and riparian vegetation. These non-field, near-channel erosion sources are now the largest source of sediment pollution to the Minnesota and Mississippi River watersheds, and because phosphorus binds with sediment, this is now a major source of phosphorus pollution downstream. And then lastly, I want to touch briefly on a BMP bypass effect. This is a subtle effect, but it's important because we've invested a lot publicly in surface BMPs. Contour strips, stream and ditch buffers are a variety of surface BMPs. But when we've changed the hydrology of the agricultural landscape, we're taking water, putting it down in the soil, and bypassing those surface BMPs by discharging water directly into surface waters, thereby reducing the effectiveness of these surface BMPs the taxpayers have often already invested in up on the surface. The water doesn't go through them anymore. A stream buffer's ability to reduce pollutant discharge to a stream is severely hampered. These impacts draw us to the question of system accountability. I think somebody used the phrase Wild West, and we think that's apropos. Right now, there's no permitting required for the installation of drain tile systems in Minnesota. There's no reporting required of where, when, and how much land you drained and where those drainage systems discharge to. There's no licensure requirements for installers. There's no monitoring requirements for the installation of BMPs and what kind of water quality and water yield we see. There are no BMP requirements for the installation of these systems. You don't have to put any kind of conservation structures on them. And drainage system operators and ditch authorities are not responsible for water quality or quantity that they discharge to our surface water. Given the scale of nitrate problems, pollution problems to Minnesota's surface waters, it's clear we're not going to achieve our long-term water quality reduction goals and meet our obligations to our friends downstream in the Gulf of Mexico unless we can start to get a handle on some of these drain tile-related pollution sources. And with that, I'll pass it on to Daryl with Clean Water Action.
Thank you, Madam Chair and members. My name is Daryl Gerber, and I'm the Program Coordinator for Clean Water Action in Minnesota. And we're a member-based organization with over 40,000 members working in Minnesota, working to protect our environment, health, economic well-being, and community quality of life. And thank you for the opportunity today. It is important to recognize the significance of both of these reports, the nitrogen in surface waters report and the condition of groundwaters report, and the quality of the work done by the Minnesota Pollution Control Agency, especially their reliance on science to communicate a pretty sobering picture of our current situation and also the inadequacy of our current practices to deal with nitrogen pollution in both surface and groundwaters. The connection between the two reports has been made very clear with a couple key excerpts I pulled out. One is that nitrogen leaching into groundwater below crop fields contributes to about 30% of nitrogen in surface water statewide. And then also that the median concentration in shallow groundwater underlying agriculture areas was about 9 milligrams per liter. The importance of that is, we've heard the 10 milligrams per liter drinking water standard. I mean, the median is just barely below the health-based standard. Of course, this varies by region. The groundwater is a pathway between cropland and surface water for about 58% in the karst region, but only 16% in the Minnesota River Basin. And we've already heard that in central Minnesota, about 40% of shallow aquifer wells have nitrate levels above the maximum contaminant level, or the MCL. The topic of nitrates in drinking water is not a new one for the legislature, but these reports show how much of a challenge remains. On top of that, the 10 milligram per liter MCL for drinking water was set by the U.S. EPA quite some time ago, and was set in order to protect against the blue baby syndrome, which has been a long recognized problem for infants that ingest high nitrate drinking water. Unfortunately, more recent research points to the endocrine active properties of nitrates as well, and there is growing awareness of the potential need to actually decrease that level, in other words, to make it more protective. The PCA is also currently working to establish levels of nitrates for aquatic life, and we have yet to see what those values turn out. So while we have been talking about the 10 milligrams per liter as an important number, we should not rest our hat on that too much, because that is going to be changing for a couple reasons. And beyond the public health impacts as brought up, we also have to recognize the direct cost of Minnesotans. Public water suppliers are required to deliver drinking water that contains nitrate levels below the MCL. And there's been a number of people talking already about the costs, and I believe that you actually had an article from the Des Moines Times in your packet today, where the Des Moines Water Works was required to install a $4 million nitrate removal plant, which when it's turned on costs $7,000 a day to run in order to bring their nitrate levels in their drinking water down to safe levels. And then private well owners sometimes have even more difficult choices given their more limited resources. But really, the question we have to ask is who should bear the cost of the impacts of agriculture on our drinking water? And to be fair, I would say who also has to bear the costs of our chloride pollution in our drinking water? And really, that's what really a lot of the public policy discussion needs to be around, is who is going to bear that cost. The scale of the problem is extensive, yet it is not insurmountable. There are solutions available if we choose to make use of them at the scale appropriate to the problem. Agriculture is and will always be an important part of Minnesota's economy and heritage, but so are our water drinkers. I'd also like to close by pointing out another important area of interest in the groundwater report, and that is that the report found the presence of a surprising number of contaminants of emerging concern in our groundwater. And several studies have found an array of CECs in our surface water, but the picture has been less clear as far as our groundwater until these studies came out. The fact that they are contaminants of emerging concern means that they often don't have the wealth of information as to their impacts on our health and aquatic life. And I want to recognize that this committee has taken important steps to fill these gaps by funding nationally leading programs at the Department of Health and the Minnesota Pollution Control Agency. Unfortunately, this continues to only nip at the edges of the problem. There are over 80,000 chemicals in the marketplace, plus medications, and these stressors to municipal drinking systems. And given that there's a lack of effective regulatory policy for these chemicals, the stress will continue. And unfortunately, given the current status in the federal level, we need to look at the states as an incubator for some of these solutions. Thank you.
Thank you, Madam Chair and panelists, and I apologize I had to step out for a while, but you mentioned the methemoglobinemia impact on infants, but there are other water users, and there are water users in the ag area. So are you aware of any data on the impact on high nitrate levels in water on young piglets, baby calves, small poultry, and the turkey or chicken production impacting the rate of gain and growth, where the high nitrate impacts the oxygen transfer in young animals?
Madam Chair and Committee, I don't have those numbers at hand, but I know that there are similar values. I believe they are higher. But they do definitely have impacts, and there have even in Minnesota been impacts of some farmers with their animals dying because of drinking nitrate water, groundwater, and thus the farmers having to actually re-drill their wells. I can get you that information. I guess, but I don't want to.
We can try to get some information on that for the committee.
Thanks, Madam Chair. Mr. Russell, I think I heard you correctly, but did you say that there is no permitting necessary to do tiling in Minnesota?
Madam Chair, Representative, there are several counties that require local permits. Right now, I'm not aware of any state-level permitting system to track the installation of new drain tile installation in Minnesota agricultural fields.
Well, on the federal side, you have to go through FSA. Corps of Engineers can have a say. On the state side, DNR can put a stop to tiling. You have Bowser, you have your SWCDs. I think there's several layers of permitting needed in Minnesota for tiling. It's not as easy to just go out into a field and tile anymore. It simply is not done, in my experience.
I'd like to address that. That's if you're draining wetlands. You can tile any upland areas you like without any permits. If you're draining wetlands, there's a whole series of regulations that farmers are largely exempt from, and you have to prove that you're exempt.
That wasn't mentioned. He just said no tiling is permitted. Yes, I agree that wetlands are different, but there is permitting required to tile in Minnesota.
I think we can get some clarification on that. That would be, we can ask House Research to get some clarification on that. Karen, did you have a question?
Yeah, I was just going to say, could we get some information on when those, when that's changed? Sounds like there's different parts that have come at different times. I'd just like to know when it changed. So imagine some of that tiling is pretty old, some of it's new.
We will get additional information for the committee on that. I do hear a concern. I don't see any other questions for you all. Thank you. Is there anyone else in the audience who would like to testify at this time? We will have time tomorrow too, but I would welcome anyone else here today.
Madam Chair, and I know it's hard with the shutdown, but there's a lot of people in the audience. Is there anyone here who's off-duty federal employee from NRCS or FSA or looking around? because I think that's, some of these things are federal issues and there's federal money, but for 7 days now, what that means is a little unclear. So
If you're here, we certainly appreciate it. Okay, and the last thing we have on our agenda is MPCA has I believe it's a draft nutrient reduction strategy, and if you would give us, is this draft or is this complete? That would be the first helpful thing, and Rebecca Flood.
Madam Chair, members of the committee, my name again is Rebecca Flood. I'm an assistant commissioner doing water policy at the Minnesota Pollution Control Agency. I also chaired the interagency team that put together this draft strategy. It is indeed a draft. It has actually been released today in order to start a public comment process, so it is indeed a draft. And I'm pleased to be invited to present the draft to you today. First, let me take a start with a brief background on one of the main drivers for this nutrient reduction strategy, and that is, as people have said already, hypoxia in the Gulf of Mexico. Each year, hypoxic water mass with oxygen concentrations that are less than 2 milligrams per liter form in bottom waters on the northern Gulf of Mexico continental shelf. Low oxygen conditions threaten living resources, including humans, that depend on fish, shrimp, and crabs. Nutrients from the Mississippi River watershed, particularly nitrogen and phosphorus, fertilize the surface waters to create excessive algal biomass, whose decomposition in the bottom layer then leads to oxygen distress and even organism death in the Gulf's rich waters. Gulf of Mexico hypoxia was first documented there in the 1970s. The size of this low oxygen area fluctuates annually, but this summer was approximately the size of the state of Massachusetts. As a result, a national task force was formed and issued its first action plan in the year 2001, as required by the Federal Harmful Algal Bloom and Hypoxia Research Control Act of 1998. The plan was revised in the year 2008, at which time all task force members agreed to develop state-specific nutrient reduction strategies for the Mississippi River and the Gulf of Mexico. This agreement, as well as our own concerns in this state about nitrogen and phosphorus pollution, are the main drivers for the development of this strategy, which began last year. It should be noted that the goal of the action plan is to reduce the hypoxic zone, but not eliminate it. The hypoxic zone goal is 5,000 square kilometers, and the size this summer was over 15,000 square kilometers, which is approximately 5,800 square miles. Minnesota takes being a headwater state very seriously. We're uniquely situated at the top of 3 major basins: Lake Superior at the head of the Great Lakes, the Red River of the North flowing north into Manitoba, and Lake Winnipeg, and of course the Mississippi River flowing down into the Gulf. And all of these downstream waters have significant issues related to excess nutrient pollution. Minnesota began our effort to develop this draft strategy last year after receiving the financial support from the U.S. Environmental Protection Agency, as well as the support from commissioners and administrators of agencies involved in the development of the draft. This presentation and the release of the actual draft strategy document today is the starting point for discussion of the draft strategy by interested stakeholders and the public. Our draft strategy has involved numerous partners, uses current science and data, identifies new technology and research needs, works with within existing regulatory structures, fits into existing programs, sets realistic, achievable, short and long-term goals. We intend to track our progress and provide for adaptive management as we learn things and move forward. The development of the draft strategy has been a collaboration between federal, state, and regional agencies, as well as the University of Minnesota. The purpose of our strategy is to guide state-level programs and recognizes that other state and federal agencies are developing their strategies too. And we know it will take collective actions of all of these entities to address Gulf hypoxia. The Minnesota draft strategy sets both short and long-term overall objectives, and I think we're unique in among the states in picking some short-term interim milestones. Because of the passage of the 2006 Clean Water Legacy Act and the 2008 Clean Water Land and Legacy Constitutional Amendment, we are uniquely situated to integrate this strategy into all of our watershed work, which we intend to do. All of our watershed monitoring and assessment work, the development of watershed restoration and protection strategies, or RAPs, and the targeted restoration and protection activities will fit into this broad strategy framework. Because we have the science and the data, we are able to set quantifiable goals to protect downstream waters and can measure our progress toward achieving them. And again, I think uniquely, our ability to do our monitoring and assessment work is going to be able to allow us to track our progress and make changes as we move forward. As you saw from Mr. Wall's presentation earlier, our current data show that southern Minnesota is a high priority for further action for both nitrogen and phosphorus. And in the Mississippi River Basin, the priority sources, as he mentioned, are for phosphorus, cropland, agricultural cropland runoff, point sources, stream bank erosion, due primarily to altered hydrology that has increased stream bank erosion, and the total phosphorus from this source is mainly attached to those eroded soil particles. And for nitrogen, the primary sources are agricultural tile, drainage, and cropland groundwater. Our state has an increasingly effective regulatory structure that can advance the ball on nutrient reduction. For example, for phosphorus, we have developed lake eutrophication standards that are ecoregion based. In addition, we have turbidity and total suspended solids water quality standards, which we use to establish what are called waste load allocations and load allocations as a part of total maximum daily load studies, TMDLs, or our RAPs. These establish local targets for water quality protection and will reduce total phosphorus in our lakes, including Lake Pepin, which is a natural reservoir of the Mississippi River. In addition, we will be noticing for public comment in November river eutrophication standards that we expect to be in effect in 2015. And so though both of those eutrophication standards are primarily focused on phosphorus reduction. As it regards nitrogen, we have a standard for nitrate in drinking water, as was mentioned, and we're working to develop a nitrate standard based on aquatic toxicity. We believe that these standards will protect both in-state nitrogen and phosphorus-related water quality, as well as long-term out-of-state downstream needs. We're setting long-term goals as well as establishing those short-term milestones. And the goals complement the existing state-level approaches, and we are unique among states having set those interim milestones, as I mentioned. We are suggesting short-term milestones so that we can track our progress in meeting the long-term goals and do course corrections as we need to do so. We have developed draft goals and milestones for each of the three major basins, including the Mississippi River. We are agreeing with the hypoxia action plan goal of a 45% reduction in both total phosphorus and total nitrogen for the Mississippi River, and we're setting a time frame for achieving that by 2045. In the meantime, those shorter-term milestones are interim measures of progress. They balance meaningful environmental outcomes with achievable action strategies and take into account the changing landscape, regulatory environment, and changes in best management practices over time. We think that there are existing programs that can be utilized to achieve the shorter-term milestones. We've made progress in total phosphorus reduction, as I'll show you in a minute. We have a suite of best management practices to address priority sources and key watersheds. We identify load reductions and the scale of actions needed to achieve our milestones. And we've found through pilot testing of agricultural best management practices that they can be effective. As a result, we need to scale up their application throughout the state to achieve needed reductions from the agricultural sector. We need to task our existing programs to optimize our reductions, and through our extensive monitoring network now in place, we'll need to be able to track our progress. And we think that when we're off track, we'll look at creating new programs, initiatives, and incentives. By providing this information to our local partners, they will be better able to use this information to inform their own local watershed planning and implementation activities to achieve local and downstream goals. So now on to what the milestones actually are. And because we've made progress on total phosphorus reduction, we're suggesting that a milestone of a 35% reduction in total phosphorus is achievable by 2025 in the Mississippi River. We have developed these scorecards, which can be used to easily and we hope clearly communicate what reductions are needed and how much we've already achieved and how much farther we have to go. As you can see, we have already achieved a 27% reduction in phosphorus since our baseline year of 2000. There's been an 8% reduction from the agricultural sector and a 19% reduction from wastewater discharges to date. The scorecards also contain actions such as best management practices that we're recommending be used to achieve the noted milestones by sector. By using agricultural best management practices such as increasing fertilizer use efficiencies and increasing targeting living cover, and field erosion control could result in an additional 6% total phosphorus reduction. However, the story is not the same on nitrogen. Levels have basically stayed flat statewide in the Mississippi River Basin since our baseline year. And because we've not made as much progress on total nitrogen, we're suggesting an achievable stretch milestone is a 20% reduction by 2025 in the Mississippi River. This nitrogen scorecard shows that a 1% reduction has been achieved by the agricultural sector, but basically that's been offset by a 1% increase in wastewater discharges, primarily from population growth. Our nitrogen study is the scientific underpinning for the suggested nitrogen reduction that we think can be achieved. For example, the draft strategy looks at increased fertilizer use efficiency, and if there were an 80% adoption rate of the University of Minnesota's recommended nitrogen rates on 13.2 million new acres, our study shows that we would expect a 13% reduction in total nitrogen. For Lake Superior, we're targeting a 3% reduction for total phosphorus and a holding of the line on total nitrogen. And then for the Red River of the North, our milestone is a 10% reduction in total phosphorus and a 13% reduction in total nitrogen. By the end of 2015, we will have completed HSPF model development for all of our 81 major 8-digit hydrologic unit code watersheds through the support of the Clean Water Fund. HSPF is a powerful land use-based model supported by US EPA that incorporates many different data layers within it, as well as our water quality monitoring information. As a result, we will then be able to model different BMP adoption rates and model their impact on local water quality. We're working with our local partners to make this information useful to them so that it helps drive local decision making. And we believe that reductions made to improve local water quality will also be a benefit to the hypoxia problem in the Gulf and will help us achieve those goals as well. We need to step up our existing strategy implementation. For agriculture, that means increasing adoption of agricultural BMPs, optimization of nutrient applications, education and involvement, research, demonstrations, and then we need to scale up those activities into larger full-scale programs. For wastewater, it means continued implementation of phosphorus reduction, monitoring of phosphorus and nitrogen, and preparing for future nitrate and river eutrophication standards. And it's just been interesting to me as also the state's representative on the Gulf of Mexico Hypoxia Task Force that Many states don't even require their wastewater facilities to monitor for things like phosphorus. So there's a wide span, a wide range of different types of activities among the Mississippi River Basin states. As a state, we plan to create an accountability team, develop statewide nutrient reduction strategy, education, and outreach campaign, integrate basin reduction goals with local water planning efforts, integrate nutrient reduction strategy tracking into our key programs, create new statewide nutrient reduction incentives for voluntary or industry-led BMP adoption, and develop mechanisms to improve state agency and federal agency data sharing on this information, and committing to adaptive management. And as we are reviewing new ideas, such as developing markets for technologies for use of perennials, as this committee is aware, our department, Minnesota Department of Agriculture, is developing the Minnesota Agricultural Water Quality Certification Program that is now recognized in statute and received an appropriation this last session. This voluntary program has the purpose of accelerating the voluntary adoption of agricultural best management practices, specifically for water quality protection. To date, our MDA has, in consultation with the Board of Water and Soil Resources, Department of Natural Resources, and the PCA, has so far developed a farm field assessment tool with the assistance of the USDA Natural Resource Conservation Service. This tool evaluates the impact of farming practices and how farm practices would need to change in order to become certified as protecting water quality. MDA has also selected 4 pilot watersheds and have started work with local producers in those watersheds. We see great promise in this program, and we're working hard to make it successful. So beginning today, this draft strategy is available for public review for 60 days. We're very much looking forward to getting feedback and comment from the public. I think our stakeholders bring a great perspective and ideas to our work and help build a better strategy, as well as spur local implementation. So remember, this is a draft, and we want that wider conversation. We greatly appreciate the participation of our federal, state, and regional partners in the development of the strategy. And I'd be happy to address any questions you may have.
I'll start off. You state your goal is to reduce the hypoxic zone. What about a goal to reduce the nitrates that are getting into folks' drinking water, whether it's a local well or community well or their own backyard well?
Madam Chair, members of the committee, the purpose of the draft nutrient reduction strategy is really meeting the agreement to the U.S. EPA that we would address nutrients in surface waters. However, with that said, if you protect our surface waters from nitrate and phosphorus pollution, you'll certainly be protecting our local groundwaters.
Maybe we're doing this backwards. Maybe you should be saying our goal is to protect the groundwater that people are drinking in Minnesota. And if we do that, we will have at least 30% reduction of nitrates, probably more. It seems like we're looking off, and I appreciate looking off to what's going on in the Gulf. But what about our neighbors who are paying right now for, what was it in the St. Peter, $18 million? Or was it $16 million for a new system? What about people who are putting in a new well at thousands of extra dollars?
Madam Chair, members of the committee, I think that we do have a variety of different activities among the state agencies looking at groundwater protection.
We're looking at them, that's true. I would agree with that. Does anybody else have a...
Well, I have a couple questions. And first, you didn't really talk much about what the human dimension of this is and who is going to be responsible for this. How do we engage this? At LCCMR last week, we had a group that was here kind of in the trenches with the BMPs, and Linda Meschke from Rural Advantage said that 10% are non-adopters and 5% are early adopters and 85% are out there kind of just not getting there yet. So how do we do that? I was asking questions earlier today about, the pollution per person. And when I run those numbers, if we only have 50,000 or 80,000 farmers in the state, that's a big number. That's fewer than the students at the University of Minnesota. So why aren't we getting there, and what are those challenges? How are you going to address the challenges of getting this 90% compliance that you need to meet this goal?
Madam Chair, Mr. Broberg, I think a lot of the answer here is working on development of the Minnesota Water Quality Certification Program. I think those types of activities are specifically designed to protect water quality, and I think after our 3 years worth of piloting that work and applying that learning statewide will, I think, really benefit water quality.
Madam Chair, another question. There's been a federal judge ruling on this related to hypoxia just recently in the last week or so. Can you tell us what the impact of that is on dealing with nutrients that go down into the Gulf of Mexico?
Madam Chair, Mr. Broberg, it's my understanding that court ruling basically directed EPA to make an affirmative decision. I believe that EPA made the argument that they didn't have to decide whether or not water quality standards for the Gulf was needed. The ruling, as I understand it, indicates that EPA does not have the latitude or the flexibility to not decide. The court has ordered EPA to make a decision about whether or not water quality standards are needed for the Gulf within 180 days. That's my understanding of the ruling.
Madam Chair, what impact would this have on your plan if they came and said they have to have water quality standards? It would be one thing. If they say they don't need them, it would be another, I assume.
Madam Chair, Mr. Broberg, it's my understanding then that if EPA makes the determination that, yes, water quality standards are needed for the Gulf of Mexico, they would work to develop those standards, do the science that they need to do in order to figure out what are the appropriate standards for the Gulf, adopt those, and then those would drive other types of activities in terms of assessing the waters and figuring out whether or not they meet those water quality standards or not.
So nothing in a hurry.
John?
Thank you, Madam Chair. I wanted to go back, talk just a little more about the BMP, the use of them, and looking at pages 6 and 7 on your PowerPoint. And what I'm looking for is, I was in the same meeting the other day at LCCMR where we were discussing BMPs, and is there a manual book that you go by that says for every 100 acres that BMP X is utilized, we get a phosphorus reduction of, Y and a nitrogen reduction of another, quantity? Does that exist? And if it does, could you share that with me anyway? The committee might be interested too, but I certainly am. The empirical data that supports that.
Madam Chair, members of the committee, the Minnesota Department of Agriculture does have a manual of best management practices, so it's kind of the suite of all the best management practices that can be applied. I'm not aware that there is something that says then if you apply these types of practices, you'll get X% reduction, because I think it's a lot of it is based on individual properties of the fields. However, as I mentioned in my presentation, we're working to develop computer-based models for each individual 8-digit HUC across the state, that we will then be able to use those computer models to do exactly what you're saying, look at application of different practices within those smaller watersheds, and then use that to predict whether or not we'll be meeting water quality objectives at the discharge point of that major watershed into the larger rivers. We don't have that currently for all the watersheds in the state, but we're working on that as a part of clean water funding.
Quick follow-up. Do you have, or perhaps it's ag that has this, export coefficients for phosphorus and nitrogen for these 8-digit HUCs?
Madam Chair, members of the committee, I'm going to look to my computer expert people over there.
Madam Chair, I'm Wayne Anderson of the Minnesota Pollution Control Agency. We worked with a consultant as well as the University of Minnesota and others that were part of the study that was described earlier by Mr. Wall, and they've developed several mechanisms to help us quantify the effect of BMP. Some of it is the national model, the Sparrow model, which does provide sort of the relationship of one watershed to another as we contribute to downstream loading. We've also looked at the effect over time relative to BMPs that have been installed and looking at that larger effect. So the analysis we're doing is scaling up from that effectiveness of what happens on your field and what might a BMP do there to, as we start to look at the suite of BMPs that we put into a watershed, what is the effect of that then as we start to cascade downstream to Lake Pepin in Minnesota, the larger river systems, and then on down to the Gulf. The report itself is a fairly large report, and so you'll want to look into that, and we'll be out having discussions with stakeholder groups and the public relative to how was this all calculated and estimated.
Just, Madam Chair, I'm a little perplexed, but perhaps because there are those who want to evaluate BMPs to see whether or not they've worked over the last 20 years, and my question is, okay, we've been doing this for a while, and we have. We've been doing BMPs since the 50s, right? And golly, I thought we should have a, bam, yeah, if we're doing 10 acres in this type of soil, we're going to save, so many pounds or tons of nitrogen or phosphorus. I really thought those numbers might be there from people that have been out there taking water samples and runoff, but.
Madam Chair, members of the committee, the Board of Water and Soil Resources also has a tool where producers can enter information about what practices they've installed and what types of soil conditions are present and that sort of thing, and then the amount of phosphorus and nitrogen reductions that are achieved are estimated through that model. So it's taking average conditions of reductions from best management practices and then trying to do some estimations in terms of how much reductions are going to be achieved through the application of best management practices. So there are some tools to do some local estimating. There's also some verifications that are happening, again, as a part of the Department of Agriculture's BMP manual, and there's always ongoing research, including some of the Discovery Farms activities that are looking at monitoring edge of field so they can actually measure the improvement from the application of certain best management practices.
One final, if I may. I would just challenge you all to, I'm wondering how you're getting to 35% and 20% in reductions and using BMPs, and you're obviously going to work on those. I see that you've got built in here to modify, but I'm really wondering how you get to the 35% number, how you get to the 20% number, and where's your base? How are you getting there with using BMPs? So I'll just leave it. It's not a question. I'm very curious.
Thank you, Madam Chair. So, Mr. Anderson, don't leave yet. Just trying to remember, checking my memory, that when you and I would sit around stakeholder tables looking at BMPs and reviewing with Jim Anderson the nitrogen fertilizer BMPs, that was probably in 1990, 1991, statewide BMPs, and then BMPs per region. Is that right? 90, 91, 92?
Madam Chair, Representative Hanson, I believe that is right. We've been at this for a little while. I think BMPs aren't particularly new, except in the area of nitrogen management. We're learning much more about that. I think we have a lot of experience relative to phosphorus reduction. Sediment reduction's been around for quite a while and has been the basis of really most of the BMPs were developed around conserving soil. And we understand them the best for that. We're learning more about what really works in the area of nitrogen management. We're also seeing that where the BMPs have really been effective is in the areas of sediment reduction and phosphorus, and that's why we're able to go to a farther milestone for that particular nutrient than we are, where we're more of almost at a starting point relative to. We've made some advancements in agriculture. They've really kind of been offset by our urban sources, and so we really have kind of been in a holding position on nitrogen. We need to move forward in that. I think the BMPs are fairly effective. If anything, it may be that we just have not understood the scale that we really need to be applying them at. That we're finding that we're probably going to have to scale up our level of implementation from what our programs have supported in the past.
Madam Chair, and so back then there was hope with the new technology, a variable rate technology would be widely adopted, and we'd have efficiency because the market would drive that with new technology, and that's been implemented over the last 20 years. And over that 20 years, we've invested in, I think, statewide LIDAR mapping, soil surveys, identifying priority areas. The cost, I forgot about the cost share, the millions and millions of dollars a year in cost share to pay for the best management practices, the 75% cost share. So I'm not sure we have any other industry that has had so much help from the public to achieve these, because there's been the university research to develop the BMPs, that's publicly paid for. We still have the university coming wanting to evaluate the PMPs. We provide public money through cost share. Air quality, mining, forestry, cities, sewage treatment, I'm not sure anywhere else where we provide that. And that's my question with the draft reduction strategy is more of the same going to achieve these goals to change behavior without a massive investment of public dollars to industry?
Excuse me. Madam Chair, Representative Hanson, there still is a great role for the public institutions. The university needs to provide more understanding of what will work, where are the causes, how do these pathways work. We've got to get beyond this first phase of a 20% reduction to get to the second and third phase where we get to 45% reduction. We probably can't do that with the BMPs we have today. There's a great knowledge ramp-up that's going to need to exist relative to maybe some of the best ideas that are out there today, but aren't really adaptable by the large group. We also have some high capital cost activities. The interception and treatment type off-field BMPs have higher capital costs. I think there's still a great role for assistance there. But nutrient efficiency is largely an industry program. The biggest reduction that is going to occur is a successful industry effort to really sort of fine-tune and achieve that higher level of efficiency that's good for their bottom line and good for the environment. It's hard to get beyond the idea that to avoid risk, a little extra fertilizer isn't a good thing. It's not necessarily about just the economics. It's about avoiding the risk of what you could be making in the very best years. And so we need to look at what kind of a risk support program would there be so that industry, who are the ones working with farmers on fertilizer efficiency, it isn't largely the government programs, it's industry. How can they be just as effective as possible relative to achieving greater accomplishment of efficiency?
Madam Chair, I have a question. We had one farmer today really talk to us about how he has dealt with, alternatives to going out and buying MPK. He's doing organic farming. Is there going to be any in your draft plan? Have you included in there measurements around what happens when you do organic farming, where what you're applying to the soil is probably something like compost, instead of a bag of the nutrients that you buy called fertilizers. Are you going to do that? Is that something you've considered? And if not, I really want to highly recommend that you look at that, because I thought his discussion about not only not applying those kind of fertilizers, but also an incredible increase in production. And farmers are about feeding the world. And I think that that testimony was very, I thought, strong, and I hope that you were listening, and that can be looking at the issue of organic farming and how it is differentiated from other type of farming methods as part of your draft. Or if it isn't, would you please put it in there?
Madam Chair, Representative Clark, that's not something that we called out specifically as a method to reduce nitrogen fertilizer or phosphorus fertilizer application. Kind of considered as an overarching strategy.
I think one of the keys in fertilizer management is looking at all the sources. One of the things that we have seen is that where farmers are only following corn on corn with a commercial fertilizer, they do pretty well because they kind of have that down. But then as they start to sort of add the other sources, they add manure in there and they add other green fertilizers, I dare say that farmer is thinking about fertility. He's just not using commercial fertilizers to do it. He needs to also be effective and efficient in his use of those. We have people just applying manure, and they can over-apply that as well. And so it's not about just the source. It's about really thinking. And I think what that farmer, I heard him saying, is he really thinks a lot about how he's doing it. He's looking at his soil health. And all of that is creating a system that for him works and likely is a very efficient system as he described it.
So, Madam Chair, that means that you might be interested in measuring that and putting that into your draft. Is that right? Is that what I'm hearing? Openness to doing that?
Well, we're at the point, Madam Chair and members of the committee, of taking comment, and certainly we're happy to take that as a comment.
Anything else? Well, this is the Budget Committee, and I don't see a budget in here, but I have the expectation that you will be looking for public dollars, and it does seem to me that any plan that you put forth should have some long-term budgets that you can tell to us and to Minnesotans who would be expected to pay for it. Representative McNamara, I'm sorry I missed you.
No, Madam Chair, it was after the testifier is done. Just a question about tomorrow.
Oh, well, let me start with saying that we're going to meet at 9 and not at 8. Some people had heard at 8:30, some people had heard 1, and then some people heard another, so we will do 9 o'clock.
Okay, thank you, Madam Chair. And I will bring donuts for tomorrow morning so that...
Oh, my gosh.
From Emily's Bakery in Hastings. Madam Chair, what will be the plan? I know you've got a couple different things on the agenda. It looks like they were later on the agenda. How long are we going tomorrow? And do you have time allowance for some of the, like, there's a couple issues towards the end. How long are they just going to be short? Or are they going to be longer? Or what is the plan for the different issues?
I would not expect the hearing tomorrow to be as long as the one today. But we have also offered public testimony, and we didn't have nearly as many people sign up for tomorrow as we have today. But if people in the audience would like to testify, we will take that. So it's a little hard for me to judge based on that.
So, Madam Chair, the couple of issues, the shoreline grants and the CARP and the water management area, are they just going to be short, just a few minutes? Because it's your plan to not break for lunch, to be done by lunch?
I would assume we'd be done by lunch. And we're going to do the shoreline in November. We're going to do the shoreline in November. We're going to do CARP and the updates on groundwater management areas, CARP, and what's the third one? Oh, the new designs for public accesses so the water just doesn't funnel back into the lake or river. So those would be the 3 updates.
Thank you, Madam Chair.
Madam Chair, and I know some of the agency folks are still here, and over the summer, some of us were at conferences, particularly relating to the Great Lakes, where there was information about personal care products, specifically microplastic beads appearing in water, and we've been talking about groundwater and surface water, and if possible, if the agencies could just give if there's anything that's occurring on that at the state level, any research. It doesn't have to be in-depth, but just a check-in back to the committee tomorrow of, I think the agencies are here to just give, if they're doing any work on that, I think that'd be useful as we're getting more and more data coming in on that.
I think the agencies have heard that and could update us tomorrow, and if you have a longer presentation, we can schedule that for November. Anything else? Thanks, folks. You're a great audience.